Kevin, when you guys go out, go to that. See.
The platform. Okay.
Yes. Yes. It's going to be recorded. Test. Test. Thank you everyone for waiting. We'll hopefully get started very soon. Like people talk.
But I'm guessing once you use like that, it'll
Okay.
drop that out.
Interesting. Well, yeah, especially when the actual ad starts, it's going to be on these numbers. So hopefully that won't be too much of an issue. And I think it will mostly pick up the sound points.
Yeah, and when you mute HDMI, it's just this one.
Yes, HDMI right here. For now, I think we're okay. It's mostly the tech, but these guys detect more. And then once lunch comes around, I can help out with that. We're pushing it back to 12. We added these new speakers in. But yeah, what time?
I can shoot like
And while you guys are in the audience, if anything goes wrong or if it's in the virtual platform, you guys can log on to that. Make sure everything's running smoothly. Oh, yeah, about that.
Yeah, we couldn't honestly.
Wait,
yeah, you can't
RSVP.
It's on your computer, though, right?
Yes. So yeah. If you want to go out there, sure. Okay. So we're just wondering, you guys, if there's any issues. Yeah. Photos for just
Of you, of me.
I guess I'll have one of my
Also, it was on the second row.
They're on the second group.
Yeah,
Second group is
but I have a bigger one of you
That's,
in the slides to come.
that's. I'm just making a joke.
When you were walking over there, how long is the are you doing this now? Gotcha, just making sure.
All right. So, hi everyone, and thank you so much for coming here and joining us. Welcome to this first ever North Carolina DevFest. It's great to have you all here. It's been brought to you by GDG Chapel Hill, GDSC at UNC Chapel Hill, GDG Asheville, GDG Charlotte, and GDG Cloud RTP. So it's been a big effort. So we thank all of you for being here, and we hope you really enjoy this. As you might already know, it's happening from today till the 14th, which is Saturday through Monday, in 3 locations. The first one is right here in Chapel Hill, which is where you're at. And then we have one in Asheville tomorrow it starts around 10 a.m. and it will have 3 talks. And then we have one in in Charlotte in the evening on Monday, and that will be at the Method INC office. So if you happen to be around in Charlotte, be sure to check them out. You can also attend remotely, of course. So before we get into this DevFest, here's a question to think about. Like, why are we all gathered? Why DevFest? And the answer I came up with was that, like, imagine if there was no DevFest today. There'd be no one here, and there'd be no talk being done, and perhaps little to no people would have allocated today's time to focus on building new connections and learning something new, finding new opportunities, and learning about machine learning or tech entrepreneurship. So it is events like this DevFest that make you feel like a part of a community, and you get to learn and grow. So it's a community of developers helping each other and learning new things and growing together that we have on offer here. So that's what GDSC is about, and that's what GDG is about. So if you are a student here at Carolina, be sure to check out GDSC at UNC Chapel Hill. They have lots of resources to help you out on your development journey. And if you are a professional or anyone in Chapel Hill, definitely join GDG Chapel Hill. It's even after you graduate, it's a developer group for anyone and everyone. So just visit gdg.community.dev and look for Chapel Hill. So that's about GDG and GDSC and DevFest a bit. So here's the agenda for today. You can scan the QR code and that will take you to devfestnc.com/schedule. and that will have all the details for each of the talks and what's happening throughout this whole day. So now I'll just go over all the talks that are happening. First, starting with the talk at 10:30. So we have Ahmad and Luoy, who's going to talk about introduction to data science. So it's basically going to be a talk that's focused on getting started up with data science. They're going to go through a Jupyter notebook on the cloud. Some of you might have used Google Colab before. So we're going to train a basic model, and also they're going to talk a bit about like how to get started from the career perspective in data science. Next, we have in-person speakers. We have them here. Vivek and Bhargav from the UNC Blue Sky Innovations Lab. So they're going to talk about the awesome stuff they are building in there. And we also have Jackson from the same lab who's going to be joining us remotely. So they're going to show you some, I believe, computer vision project, and there's also a pretty cool robotic arm project. So be sure to check that out. Then we have lunch at 12:05. So we have pizza, and also we got snacks and drinks right out there. So just grab them whenever you want to. After lunch at 1 p.m., we have this talk from Rabimba. He was a researcher at Mozilla Research, and he's going to talk about how they built deep speech and achieved a less than 10% error rate. So deep speech is an engine that takes speech and converts it into text. And this is going to be an ML talk, and he's going to show how to use deep speech and then also get into the mathy part of it. And then we have Chris, who's going to talk about tech entrepreneurship, and that talk is at 2:30. So Chris is a tech entrepreneur himself. He started calligraphy.org around 2009, and right now he works at another startup, boompop.com. And finally, we have John, who's going to talk about TensorFlow from the ground up. So TensorFlow, as you might know, is Google's library for machine learning, not library, in fact, framework for machine learning. It's got lots of APIs, and John is going to throw some light on a few of them and how they work under the hood and the math behind it. And it's going to be fun. So yeah, that's our lineup. And after this, we will have a raffle, and we had announced we had one raffle prize, but we now have 3. So hopefully, and it's all for in-person attendees. So yeah, it's going to be fun. Hang out till the end and definitely have fun. All right, thanks guys.
Yeah, so thank you, for doing that for such an amazing kickoff to DevFest. And of course, thank you to all of our sponsors. This wouldn't have been possible without them, as they're listed up here. And just in case you didn't know, I am the active lead for GDSC at Chapel Hill here on campus. We're a student-run organization affiliated with Google. And throughout the crowd, there's also some of my core team here. And if you're a student here at UNC and have a passion or interest in technology or developing, I would highly encourage you to join us throughout for our events throughout the semester. We host plenty of tech workshops or professional development events. And yeah, we look forward to seeing you guys here, and I hope you guys enjoy today.
So we still have like 5 more minutes. So just grab a drink or snack, and the talk will be right up.
The talks are going to be in this room, right?
Yes.
Okay.
streaming it to YouTube.
Okay. No, I just wondered because for our labs, we have to if you are recording, then you get recorded. Yeah, we don't.
Oh yeah, we are recording.
You are recording, right?
So it will stream to YouTube, and I believe that we can also record from right here as well.
Yeah, we just want to.
Setup is working, and if it is, it should be recording.
I mean, no worries. I'll anyways record on my phone.
Yeah,
in case
yeah.
in case there's some issue.
Maybe not 9 o'clock, but
Quick question. You're part of the GDSC.
GDG. I am UNC alum, and I run the citywide GDG chapter.
Alright, so I'm going to ask about GDSC.
Oh yeah, GDSC is Andrew.
Okay.
You can also join GDG because it is like a community of software developers. So people who have graduated can also join, but there are also
Still
UNC students.
like beginning.
Yeah, that's still fine. Like, we do beginner level talks, and we often pair up with GDSC. So you can just join GDSC and still find us
What do
here.
they do? Do they like meet like every month? And like,
It depends. So when there's vacations and stuff, so GDSCs are also at vacation, but usually they meet at a regular cadence, like at least once a month.
so are you a CS student?
here because you know they put in the new additions.
Oh, that's right. Yeah, did you follow that topic on major to CS?
No.
Okay. So I know they love the class.
The presenter mode is off, or is it on? I think it's on.
Did you
Yes.
So are they unable to?
No, they are there, but can they share screen? That's what I'm thinking.
They're unable to broadcast.
No, they should be.
You might have to open up.
Oh, yeah. Yep, I messaged them.
Then they are good and you use them. You say,
I do, but it's like a self-fulfilling prophecy.
people say they're good, so a lot of people get them, and then they say they're good.
I think he's on.
You want to have them say something. That's how I am.
Is the audio on?
You guys hear me?
Oh, yeah, yeah, that's okay, good. And then we just need to change this screen.
Yep, we can hear you.
Awesome. Okay, great. Let's see. I do hear a little echoing feedback, but no problem. Let's see. All right. Get ourselves started here. So y'all can hear me, but
Can you
now
try
can you
now?
guys see the screen?
Is there a way to make this screen?
Yeah, we can see your screen.
Okay. Awesome. Okay. Well, here we go.
Yeah. So just give me 1 second. We need to make this screen larger. That's cool.
All right, just give me the green light and we're good to go.
Yeah.
Oh, and then has this been recording? Do we need to press?
All right. The stage is already.
All great. Hello, everyone. Happy DevFest, and thank you guys so much for having me. I wish I could be there with y'all. But unfortunately, I'm stuck here at Florida, but next time for sure. My name's Ahmad. I am a former GDSC lead, as well as a recent graduate of FAU, Florida Atlantic University, and a current software engineer. Louis, if you'd like to introduce yourself.
I'm Luay Abu Dahab. I'm a research assistant at FAU and doing master's degree in artificial intelligence. And I have experience as a data scientist.
Yep. And Louis here has been helping me out, especially with GDSC. So I thought, why not help me out one more time in creating a nice session for data science, and forgive me in advance if I say data. I know there's so many arguments going on, but I'll use them between, just so I can get in the middle of it all. Our objective here, ideally, we just want to go over the really fundamentals. Due to the given, short time, 45 minutes is not a lot to go over data science entirely. It's a vast, topic, and we're just going to give out the nice, I guess, fundamentals and found. And what we'll do is we'll do a hands-on, and we'll leave the rest to you all to do whatever you'd like to expand upon it and further on with this project to go ahead and make it something more applicable and of an engaging project, even something you could put on your resume. So that's hopefully our intent here. Louis, go ahead and I guess give it off to you.
Okay, so we'll start talking about what's data science. So we know, all of us know that data is all around us, from our mobile phones, sensors, our car sensors, Facebook, Twitter, and every company has its own data. And this data might be abundant or not used well. So here, the data science come to utilize this data to find the unseen patterns that we as human might not see or will struggle to see. And it might take us time to extract information from this data. So data science tool came to provide a way to explore data more and make decisions based on it. As we see in this figure, so the data science is an interdisciplinary field. It combines between the computer science, math and statistics, and domain knowledge business. So basically, you don't have to know everything about these three measures. So the only, but the team should know. So for example, if you have a project and it's related to finance side, so you need someone who has uh, domain knowledge in finance to help you through the project. We'll start now talking about the life cycle of a data science project. So each data science project, of course, starts from identifying a problem. So we should identify our problem well and understand what's beneath it in order to go further. Then we will start with collecting the data from sources we have, and then processing and analyzing this data. And then we'll create the model that takes the input, the data as an input, and then exports the decision or the thing we have as an output. So, starting from defining the problem, let's say I have a website, I have an e-commerce website, and my problem or what I need is I want to increase revenue through my website. So there's a couple of things that I know. For example, I know that I have 1,000 visitor every day, but I only have 10 visitors buying. So for example, I'll say that I want to try to build a recommendation system for these users that are not buying to recommend some product that they may like depending on what they bought earlier. So now this is how I define my problem. It's like I list my facts I have. I'll see what data can I get, and based on what data can I collect, and based on that, I'll see what I can do. The next step is The next step is data gathering. Or data collection. As we said, data is all around us. So depending on my project or what I need to do, I can either collect the data from by entering these data or getting the data from a sensor, like a humidity sensor or sensors like these things, cameras, or even let's say I have a data that I don't have access to, or it's on another website, so I can create like a scraper to get all these data from the websites I know and to save them in my data set. Or I can use open source APIs, open source databases, etc. And of course, in each project, depending on what is my project, I can use multiple data sources. The third thing to do is basically the data processing. So, as we say, we might have used a couple of sources, a couple of database sources. So, the first thing to do is to merge these things. So, the data processing part is all around processing the data we have in order to get a clean data that can be used for our project. So, for example, as I said, we start with merging the data set. And then if we have, let's say, if we have some missing values in the data set, so we try to figure out how to fill these missing values. Sometimes in some projects, we just delete the rows that have missing data set, but sometimes we can't because we might have a very limited uh, number of rows. So we try, for example, to fill these missing values with some values that may be suitable for our problem. or we might build a model, a statistical or a machine learning model to fill this missing values. We'll not go so deep into this now because we don't have time. And next, what we do, we have to make sure that all our data set is or our features looks the same. For example, if I have a data set of images, so I just have to make sure that all these images have the same colors. For example, the same color space, I mean. For example, they all, if I'm using a black and white images, so all of them should be black and white. If not, I should convert the color to black and white in order to have standardized data. And for other example, if I have, let's say, a couple of images that don't have the same size, so I should convert all these to same size images. I also, for example, check if there's any duplicates, and after that, and there's a couple of other data processing methods that could be used depending on my project. After all these things, what I do is basically save this data into a storage like a data warehouse in order to be easily to save to a data warehouse that can be easily accessed by me anytime I want. So the fourth step is basically exploring the data that I have, analyzing it. So I have to know what data I have in order to continue. For example, I should try to understand the relations between the features I have, or find the best features to be used in our solution. For example, I might have uh, a data set that have 120 columns, 120 features. So in this step, I'll try to find if I can minimize the number of features by trying to explore, let's say, if I have a large correlation between two features, so I might drop one of these feature. So basically, this steps is all around exploring my data, trying to understand what I have in order to know how to go further. And then we start with the data modeling, which might be one of the most important things in a data science project. So in the data modeling, as we said, now we have our cleaned, processed, and the data that we understand. We'll use this data as an input for the model that we will build. The model might be a machine learning model, might be a statistical model, might be a deep learning model, or might be another kind of algorithms. But basically, what this model will do, that will take a chunk of this database we have and use it to train our model. After that, what we do is we try to we'll leave a chunk to test this data, and then we'll try to feed it to this model after training it on the training model, and try to uh, predict something, and then we evaluate if this model is right or not. We'll iterate on this until we find the best model that we can get from the data we have. The last step in any data science project after getting the model, the output, and these things is trying to communicate. So now I have the information, I have the data, I have the data, I have the model that I have, and I have the output. But these things might not be readable for non-technical people. So what we should do is to build a dashboard or a report that we can show to people that are non-technical in order to utilize the tools we have. So for example, for the image we see here, this is a traffic prediction system. So it will just display the data as an image with some figures over it. So in these 6 steps, uh, we should these these 6 steps, we should do them every time we need to create a data science project. And we might reiterate on them if we didn't get a good results. We'll start now with some live examples that we might see or that you could see. So for the first example we have is a traffic prediction. So basically, let's say you have a transportation company and you need to find on this time what the best route to go through. Or let's say I have a trip next day and I want to predict if on on a specific time I could go through this route or another route could be better. So there are companies who built a traffic prediction system that tells you in a specific time that there might be a congestion or or there might be a high traffic volume. So the input of this, as we see in the next slide, so we might collect data from multiple sources. For example, from historic traffic data, from real-time traffic data like cameras and these things in the street, external data like weather, because we know weather might affect. And also another external data might be the GPS systems or Google Map and these things. We know that Google Map has API that we can use in order to get historical data, for example. And we may also, for example, gather data from users that are using an app to get some GPS data from them, for example. And then after that, we feed all these data to our model that could be statistical machine learning or deep learning model. And this model will basically export the prediction for us. Another example that we all see is a recommendation system for movies, is the movie recommendation systems, which take into account what you have seen previously. And then based on that, it will recommend some stuff that you may like. So, for example, in the next slide, for example, if someone have seen the movie one and movie two, and another one have seen movie one, movie two, movie three, so I might recommend because the first user saw the first two movie, both users saw the first two movies. So I'd I would see that these two users have similar interests. So I might recommend this movie to the to the second user. I mean, I'm sorry. So basically, there are other ways to do recommendation systems. We'll try to explore one of these ways now with Ahmed in the hands-on.
Thank you. And I kind of wanted just to go a little bit back on some things, um, first and foremost, even from what Loe speaks of, I personally experience it as well in regards to working with finance or other departments. It's not always going to be two-dimensional where it's just you as a developer or as a data science analyst that know everything. You'd have to ask, how does this translate from one table to another if need to be, depending on what department that you're working for. So it really does vary, and a lot of the life cycle is very I think accurate in what we can do in real world jobs and things involving data science and analysts. So I definitely think like it's something where we probably talk about it now, but you won't like not a lot of people understand until they're on the field like, oh, okay, I see what you're saying. That's the kind of thing that we're going through. But fortunately, we are going to be doing our own um, movie recommendation and I kind of want to go over a few things before about the filtering for this. But before that, I want to ask, how many of y'all are into data science or um, have a deep end knowledge of machine learning? You can probably, but I won't see it. So, um, okay, so I'm hoping this could be a more of a, get your feet wet kind of thing, and then you all can definitely expand on this on your own time. It will have everything sourced. But moving forward back to sorry, moving forward with the type of filters. So there are three different that are utilized in this type of project. And essentially, a demographic filter is a more generalized filter, as it shows here. It's for every user. You know, it's not going to be specially just for you. It's going to be for everyone that's recommended. And this is honestly something that you would do as a user that first enters. It's like, well, here's a large variety, and as a whole population, this is what people enjoy, right? And that's the approach to really simple. In fact, this is the one that we'll be going for because it is, as it said, it is so simple that we decided that it does cover a lot of the foundations, and it covers us up enough for the time given. Now, content based is probably the most refined and most popular because this one suggests similar items based on a particular item, right? This is what we call metadata, which is essentially data with data. Uh, let's say, for example, the movie that Lue ones that he showed, right? It was about horror and thriller. So based on these genres, and then on top of that, maybe there's a top casting of I don't know, Ryan Reynolds, right? So then they will take note of this in this system and go ahead and recommend it further on in terms of these type of genre, actor, cast, or even director. So it's these types of metadata that tends to be utilized to go ahead and recommend the user in particular of an item that they might like. And this we can see as well for YouTube. Something else can be on Facebook posts, right? Etc. So this is a very popular thing. Now, collaborative filtering is also, it takes the best of both worlds, essentially. It's the thing that matches, of similar interest and, information. And I would probably say that that would be a most common thing you'd see in things like Instagram as well when we see reels and whatnot. That's the type of thing it goes. And so I actually have a visual because I like this more. This is where we can see the metadata. We can see the horror, we can see romantic, we can see we can see the genres, and then the what the values for those. So this is essentially how it tends to tie in. And unfortunately, we will not be able to get to it within this session. However, it is something that I would highly recommend you guys continue on with later down the line. So the tools that we'll be using, to put it simply, is Google Colab as well as Kaggle. And I'm pretty sure some of you guys are well aware with Kaggle, right? It's a great website to have data and do it. So instead of scraping data and collecting it on your own, this does it for you very nicely on a silver platter. And then Google Colab. So instead of doing it on Kaggle notebooks or any other notebook, we decided to go with Google Colab because hey, we're Google. But no, but more than that, it's because it's you can put this on a GitHub repo. You can essentially even run a Colab notebook on a hosted runtime in the cloud. So it has, I feel like, a lot more tools that is more versatile. And like I said, because if you want to expand on this, this is a great way to do it and a great tool to use essentially for all starters in general. Awesome. All right. So we'll go ahead and do the hands-on example now with the given time. So what I would say here is that go ahead and take this, short link, this bit link, type it down if you can. I will probably drop it down in the chat as well. Um, I'll just leave it up there for about a few seconds, and then I'll go ahead and drop that down. Let me go ahead and see here. Okay. So. Oops. I'm gonna escape here real quick. Let's see if I can put this in the chat. Uh, all right. Oh wait, is this the right chat? Or right section? Okay. Let's see if that works. Oh, this is. I am confusing myself. All right. This is the link right here. If you guys want to go on the stage on the online, that can be a great way to do it. I'll leave it up here again. It's here. I'll give you guys a few seconds as well, one more time. Unless if y'all want to, I'm perfectly fine with that.
Yeah, Ahmad, can you give us a second? We can share the link with everyone here.
put in the chat?
Everyone in person is not logged into their online platform, so
Okay.
we need to share it some other way. So just give us a moment. Yeah.
Yeah, no worries. I'll leave that up there. And let me do anything.
Thinking we can do a QR code.
Yeah. Let's see.
Can everyone see that?
I think for the people here,
Hold on. Let me see if I can enlarge it. Oh. Um. Here you go.
So we keep it here for a couple seconds and then scale over back to the top.
And you don't have to put the HTTP. I think it'll work without.
All right, we're all good to go.
Awesome. Okay, good. So let's see if I can. I'll go ahead and put that here for me. Is out here for me. All right. Um. So what I'll go ahead and do is we'll run through this, make a copy real quick for me, save a copy in Drive. That's what you guys want to do first. Highly recommend save that copy. And then this is the notebook that you guys can go back to and refer about it. The author does a great job in explaining it. And this is just me essentially going through a walkthrough just to help simplify things. So obviously we talked about the recommendations, what it is, and here's just a more general idea of how we're going to do it. So first off, I want to go ahead and you can definitely run this because it's just the libraries. This is just for you to know. And pandas and NumPy, as well as matplotlib, are basically like the fundamentals of any form of data science you're going to do, or any deep learning too. Visualization, use it for different formulas as well as you know absorbing data. So this is great to use. These are your three essentials. sklearn, this is something that goes on to the content based as mentioned here. So up to y'all if y'all want to do this later on your own time. Enjoy it. We are going to be a little bit tight on time, so go ahead and give this a go. You're running this if you want. It, Oh, and let me know if this is too distracting for the for the animals. This is just my my enjoying slide right there. So the last thing is the data, or the last thing. The next thing is the data. So I would say here is go ahead and grab your data, and what you're gonna do is you essentially go to this website. You'll go ahead and I'll just pretty much download this. What it'll do is you notice here it'll say, hey, it's gonna be a zip folder. Go ahead and name this right? And we'll go ahead and open this up here. I'll go back to this in a second. I'll also remove this from my side. Here we go. We'll go back here. Right. And so we see here movie data set. Go ahead and extract that. We'll go ahead and extract it here. And what you'll do is you'll go ahead and oops, wrong one. Data set. You'll go ahead and click on folder right there, and you see where it says upload icon, or you can go here, sorry, the upload icon here. They'll go ahead and upload, and I'm just going to move back to movie data set here, put those there. Okay, sounds good. So I'll just tell you, hey, the pro version's better, but all of them are pretty good anyways. Perfect. So I hope this one's showing, it's loading. But once you do, just make sure that you see those inside. Pretty sure I can move forward with this unless it's still loading on my end. Not sure. What we can do is we can go ahead and run this and see. So I'll go ahead and run it. Credits. Okay, so credits to me is still loading. I don't know why, but it does seem like if I were to take, you know what I'm gonna do for fun? I'm just gonna load this one. So it runs this one perfectly. So what I'm gonna do is, if you guys have it loaded and it's showing everything there, that's fine. Perfect, awesome. Uh, so I'm still waiting on mine. In the meantime, if I can remove this guy. So hopefully once this guy starts running, we'll go ahead and continue forth. Hmm. Awesome. There you go. We'll go ahead and run it. Perfect. So we go ahead and see this. And other thing that Louis mentioned was about merging data, right? So we have these two, which is about uh, movies and credits. And essentially what you need to know is you kind of do need to know about, what are you studying? Like what table are you using this for? What features does each one have, right? And to basically give a quick rundown of this is that the first data set, the DF1, I know I ran DF2 first, but DF1, which I call it data frame because it's all encapsulated in a frame essentially. And what this will do is DF1 has the basics. It's just movie ID, the cast, and the crew. The credits, however, has the budget, has the genre, has the homepage of terms of everything. This is from IMDb, of course, so I think it would revolve around there. However, it has ID as well to identify it. And what we see is that it has a common factor of movie ID and ID. What we'll go ahead and do is merge both of those together. So we'll go ahead and say, hey, let's just put them all together in this bigger data set, which is obviously I listed a lot more than it was towards one, which was movies. I know this, I'm moving really fast, but essentially has shorter amount of attributes versus DF2 with credits. So we obviously merged it in here, and to test this out, what is we're gonna go ahead and just go ahead and test out here the table. So we'll go ahead and put DF2 dot head 5. Well, are the first 5 for us to make sure that it shows. So df2 dot head, and then you'll have your parameters here, but 5. See that it starts with obviously 0, and then it goes 4. We can see that it has the homepage for that movie, avatar, and then it goes on to original language. So it's successfully merged. Everything looks fine. Now for the fun part of filtering. What you need to know for filtering is we talked about that it does an overall population, right? It does it for the most uh, general user. You're nothing special, and it's just for everyone in total. That's where the majority counts comes in. And what you need to do is, especially in data science, is you need to start figuring out how to equate things. Now obviously it's to build a form of a metric or something that you can score it by and give it the, I guess, a form of sum. In this case it would be called the weighted rating. And weighted rating is essentially just the averaged of all the ratings combined. Is voting as well as ranking. So you have the critics and you have the users. Right? Moviegoers can be a bit different than it would be of critics. Kind of see that throughout a lot of recent movies that come out here and there. And what we'll do is we'll go ahead and establish variables for it. Let's have V, I guess, be the number of votes for a movie. And then M would be the minimum votes. And why it's important to have M as a minimum vote. It's important to have a minimum because it gives you a margin in terms of where you want it to be, a standardized data, as Loy mentioned before in the life cycle. It's about having, instead of the entirety of it and going through it, especially when you're dealing with large amount of data like big data, you'd want to make sure you're filtering through and making sure that you have a minimum standpoint. And especially for something simple like this covers it. An average rating of a movie. So to do so, what we're gonna do is we're going to go ahead and have our variable c. So we're going to go ahead and declare c here, and we'll use our table df2, right? And what we're going to do is we're going to have v to be vote average. That's the actual variable that will be used in this case. Oops, vote. Vote average is going to actually the ranking average. I know that sounds a little confusing, but vote average is essentially the rank average based on critics. And what we'll do here is we'll have that to be averaged out, right? So we'll go ahead and put the mean here, and we'll go ahead and run this. Make sure that works. Okay, cool. So I'm going to test this out one more time because I forgot to say what's the results here. Okay, so our average rating is going to be a 6, well, 6.09, but for all the movies that are there. Okay, great. So now we want to know about the minimum vote. So how can we set up the minimum here? We'll go ahead and do so with our m. As we'll have m equal to our table from our specific attributes here. We'll put it here to be votes. See vote count here. Perfect. We'll take use of that. And what you'd want to do is you want to make sure it's on this dot quantile. Everyone see that? Dot quantile. And then we'll go ahead and give it parameters of 0 through 9. Right, and so we'll go ahead and test that by doing this. Let's hope it doesn't give me any errors. And it does. Awesome. So let's see what I did wrong. So df2 m df2 phone quantile. So sorry, I put instead of comma, I should have been 0.9. I apologize. And there we go. So that goes ahead and gives us required in terms of this, and that's going to basically does is it says, well, hey, in the 90th percentile, what are the amount of votes that usually come up there? This is the amount of votes that would within that 90th percentile, about 1,838. Now, we're going to go ahead and filter out the movies that qualify. So to do this, what we're going to do is I'm going to call it qualified movies. No, you know what I'm going to call it? Q movies right here. Excuse me. So we're going to have df2 dot copy. Okay. And what we'll do is we'll copy a lot of the table, but we're going to specify where the location is going to be. So we're going to use .loc, right? And we're going to do df2 because we did this based on what qualifies for the minimum votes. So we said, hey, based on these amount of minimum votes in the 9th percentile, let's leave it that way. Essentially, what we're going to do is we're going to have that here. It's going to be votes count again, because that's what's using it, right? And then we're just going to do this, where it's going to point to the variable minimum votes of users. Is everyone following? Can I get a nod? I know it's quick. It's just or no. Okay. I'm starting to see the camera now, so I'm just double checking, and actually using it to check in with everyone. Okay, so we'll go ahead and come back here. Now, once we do this, right, what we're gonna do is we're gonna definitely see the results come out, and what I'll do, I apologize, is shape. And what shape does is basically it transforms it for us and gives us um, our results here, in which we see that 81 movies which qualify to be in the list. Now, what we need to do is to calculate our metrics. So we have all these variables. Now it's all to bring it together and find our metric movie. And to do this, what we'll do is we'll define a function, and that will be rating. And we see that actually here. I kind of left that there for us because of concern. And what I'd say here you want to do is you want to define a new feature and make your own feature in this, and that's going to be called like I think for this one is we'll calculate this, or what you see here is that it has it to be m equals m and c equals c. So what that means is if we go back, right, we'd want to make sure that it meets with the minimum votes and uh, the average rating, right, the average score for that votes. So it has to meet both of them. Once it meets both, it has to be at least what's it called 1800, 1838, and then it has to also be at least of a score of 6. So if it has that perfect, you're in the club. You're inside the movies that qualify. Um, Now, with that being said, what we're going to go ahead and do is create the formula. So we have our variables here. We defined it to be with weighted rating as our feature. We have our V's, we have our R, and looking back at it, what was it? Weighted rating versus. Okay, so R and C and WR. What we're going to do is this. I'm going to return back this equation as our weighted function. BV, and I hope you all pay attention to this part. This part gets a little tricky. Plus M. Oops. Uh, okay. Apologize. There we go. So V plus M times R. Can everyone see that? Let me see if I can zoom in a bit more. So this is what we have so far, right? Make sure I'm gonna double check here with something. Okay, that should have not been a lowercase m, V. That should have been a capital M and a lowercase, capital V and a lowercase. This morning has me caboodled. So we'll go ahead and continue on here. Right. And what we'll do is have it to be equating to C. Oh, I apologize. I should have been within here. Right, and then C. So is everyone there so far? I know it's a lot. So what that does is essentially it goes ahead and says, well, hey, um, it says go ahead to kind of replicate that equation for our metric or what we want it to achieve here. And so we see that it kind of does do that. We see that V plus M, or V over V plus M times R. We see that M plus M, and we're able to equate it with what we did in terms of you know average vote average, which is the rank average, as well as our vote counts and our scores, right? Um, Now, once we do that, we'll go ahead and work on this here. We'll go ahead and say Q movies, right? And we'll have that to be our new feature, which is score, because we want that to be our metric score in terms of what qualifies and goes in towards our demographic, filtering. So once we have this, oh, I apologize, I did not run this. Oh, and I made an issue here. Great. So what I would say is here. Wow, my issue real quick. M plus V. Okay. Okay. Maybe I'm just. Huh. What did I do wrong? Is it the V? Let me see here. Um, Let me go ahead and double check here.
We believe
I know we're running out of time, aren't we? Hey, how much time do we have left?
Ahmed, just you forgot to put it up before the return.
Oh, I'm so sorry. That's why I
I
forgot.
think
Okay.
you were Marty invented it. He found it. Very good.
And
We
Okay.
just have. So we have 5 or so more minutes. So
Okay.
before the next talk,
Yeah. Squeeze that in. So there you go with the tab. You see, I totally forgot about that. We'll go ahead and just run this through as quick as possible. Um, let's see. I wish I could have given you all a lot more than that in terms of in for like at least for the sections, but you can definitely find in the Kaggle notebook. So we'll go ahead and just put the score here, and then we'll move on forward with closing this up, and you guys can continue on later on your own time. So for the score, right? For the score, what we'll do is go ahead and put key movies to apply, because what we want to do is make sure that we apply this all in our uh, value for score. And what we're going to put here is weighted rating. Weighted rating. Get that in there? Yeah. The weighted rating, and we'll have it to be on the axis. And the axis will equal to 1.
so
Okay.
Ahmad, we just got informed from the speakers after you that you can go on for like 10 or 15 more minutes because one of their speakers is not going to be able to make it. So their talk is going to be shorter.
Okay. No worries. Um,
Take
thank
your
you,
time.
speaker. Perfect. So we'll go ahead and try to make most of this in the 10 minutes that we have, at least so you guys can get a populated or a plotted, sorry, overall popular movie for the and that way you'll have a filter. So we'll go ahead and we finally got ourselves a. It seems to check out that we have our new feature for score, and why that's essential is because we'll be using it um, to our scoring in terms of our measurements of how our popular movies are descended. So, that will be our overall with taking our votes, our average counts, and our average ranking, as well as the title, because we need that to determine which one has the overall average, top vote, I guess you could say, or top critically acclaimed movie, where it's both for once, critics and users both. In this case, we can go ahead and do, and we'll probably, speed run through this part, is we'll go ahead and to do so, we'll do Q movies equals Q movies dot sort, and we'll make sure we sort our values. So we're going to do sort values. I apologize. Um, do score. Okay. And we'll go ahead and have it to be ascending false. And this is important because this is what takes, oops, I left that in the quote. Okay, and we'll put it as false because we want to make sure that it goes ahead and descends. Awesome. Now, the fun part of printing out the top 15 movies or so is basically we told you about the title, we talked about the vote count, and we talked about um, the vote average. The vote average is the rank average, and the vote count is from the users. And what we'll do is go ahead and click on this, and you'll see that voila, you have essentially all these movies ranked from based on the popularity of the highest in terms of score that we created, and this is our own feature, right? Features is our header for our column here, and so that's what allows us to interpret it. Now for this part is a little bit more, we'll probably speed run through this just to make it nicer, because you see all this information, but like Louis said before, if you want to give it to someone that just sees it and he's just interested to see, oh, like what's the most popular movie, right? We're going to go ahead and do so. And so we did put in matplotlib up in the top, and we'll go ahead and utilize that here in a second. So we'll just create a table here. We'll just call it pop for popular, right? And do is it will sort through the values. We'll go ahead and put sort values. All right, popularity. We'll put ascending false again, because that's how we'd want to sort it. Awesome. All right, and then here. So we want to make sure we put the plot here, and this is how we do it. Oftentimes you'd want to create a plot.figure. That's a big 101 that you'd probably want to know. And we'll go ahead and leave it to be 12 to 4. This is just to give you a sized average in terms of your axis. So let's see. All right, so for here, we'll go ahead and put bar H. So this is going to be a bar graph for a visualizer. And so what you're going to do is you're going to put that here and put that table that you want to create. So you're going to put title. That's how you'd want to sort it as your thing, as well as title here, head. We'll put 6. And we'll put 6 here just because it's more simplified, it's smaller. You can put more if you'd like, up to you. But this is how I would do it just to now. You can probably put 10, 15, either or. It won't look nice, but it will definitely be there for visualize. So this one will put popularity, right? And then we'll go ahead and put 6. And what we'll want to do is, just to wrap this up, is put it as align center. Always aligning this is a very nice touch to it. Lastly, no, I said the final touch, but lastly, oh, and I forgot something. That quotation always gets me. So we'll go ahead over here we put align center, right? And then what we're going to do is we're going to put the color for our bars. I like it to be sky blue because I'm a big fan of blue. If you are too, welcome to the club. So we'll go ahead and, as you can see there. Now, what we'll do, I'm going to go ahead and plot it here. We're just going to go ahead and say plot GCA. And then we're going to go ahead and say invert y-axis because we want our y-axis to go ahead and show the bars there. It'll come out horizontally. On how much time do I have? This is like, this feels like a Mission Impossible point scenario. Probably. Oops, I am not looking at my screen.
Yeah, we have 5 more minutes for sure.
Okay, perfect. So you guys will see it. I apologize. I actually like this capitalized. And then lastly, what I'll do here is I'll have our title. So what do you guys would like your title to be? Let me ask that. Popular movies. Let's go with top popular movies. And we'll go ahead and, yeah, I guess that should be fine. See if this works. And there, so you have 1, 2, 3, 4, 5, 6. There are your 6 movies. I actually would not believe you if you said Minions was on the top, but there you go. Your filter and recommendation system is there. It would recommend from 6 of the popular movies in terms of what's been popularized on what's been given in data of the own table, right? Of average votes and average, based on our metric score essentially, but that's derived upon what? On average as well. Let's see what we put it up on. Vote count. And I guess that's it, essentially. And that's how we did it based on the titles and everything. And this is what you come up to create. And let me leave this up here just because I know I'm a slow typer when it comes to workshops as well. So I'll leave this up here if you guys want to enjoy and see. But that's essentially a demographic. And like we said before, to keep in mind, these demographic recommenders are like the basics. It's what gives you a recommend movie to all the users, and it's not sensitive to the interest of just you. But it is a good idea to put in if especially a user is entering into it. Why? Because that way they can see a more generalized thing. And once they start entering it and having, um, entering into movies and seeing what they're watching, that's when the more refined system of a content comes in and goes ahead and you can use a collaborative system as well to merge both. Okay, let me go back here. By the way, can I can I see? Can we get a good thumbs up? Good stuff. Good stuff. Okay, great. So we'll go ahead and come back here. And so I kind of wanted to go back over is that for future use, if you're interested in this stuff, go ahead and look into the Kaggle notebook. If you're interested in further studies of data science, you can do this. But because today is a machine learning and data science day, go ahead and see other great tools out there that typically they can contrapulate together in some way or manner. Hugging Face is a great machine learning API that you can use on the source for things like natural language processing, so NLP, which is if you want to do like facial recognition or anything like this. I would say the other last thing is TensorFlow. Google Colab can utilize Tensor things like transformers or models and class and neural network classes in general. Lastly, I think that would be the best thing I could say, actually. If there's no questions, thank you guys for coming. I really do appreciate it for the time and for the extended time. Thank you, An, for having me, and thank you for me in the way, actually. But this has been a true pleasure. I hope you guys enjoyed it to some extent and were able to perceive something from this.
Thank you so much, Ahmed. That was a great talk. And if there are any questions, we can pass the mic around and you can ask them anything about like even data science. If you have any general question, because Luoy, I believe, is a graduate researcher in the field, and Ahmed is a professional software engineer. So now's your chance to ask these people any question, if you like.
Yep. And I don't know, can I drop my Discord or LinkedIn on here?
Absolutely.
I'll go ahead and leave it in the chat.
And guys, if you want to follow along with the chat, you can join the event online through that event page. So if you go to devfestnc.com, click the register button, you'll get to that event page and you can click join virtual event here. And
Okay,
even
yeah,
though you're mobile, you can follow with the chat.
perfect. I'll go ahead and do that. Okay.
Did you get your Discord link?
Yeah, here we go. Do you guys see that? I think I put on the general
So
chat.
you can reach out to them on all of those channels. And once again, thanks so much, Ahmed and Roy, for the great talk. Yeah.
Thank you guys. Appreciate it.
All right, so now we will be moving to our next talk, which is going to be from the UNC Blue Sky Innovations Lab. Um, and so let's see what innovations they'll be working on.
Keyboard should work. I'll be right here. Okay. I have to help with anything. Sure. I can sit there. Hello everyone, I'm Vivek and this is my colleague Pavel. So we work at the UNC Blue Sky Innovations Lab at UNC Chapel Hill. So I'm an AI researcher and Bhargav is a computer vision engineer, and today we're going to talk about the projects that we are working on in our lab. So our lab is actually a joint venture between Hussman School of Journalism and Media and Kenyon Capital Business School. So what we do is like we take on business problems and try to solve them using any kind of technology and emerging technology, especially such as computer vision, robotics, augmented reality, virtual reality. And my colleague Bhargav is going to tell you more about it.
Yeah, so basically that's like the gist of what we do at the lab. We're a very multidisciplinary team of like students and researchers. So me and Vivek work full-time at the lab, but we also have a lot of students that work as fellows that are like, we have like marketing students, journalism students, education students. So we kind of all work together to come up with solutions using emerging technology, like Vivek mentioned, like virtual reality, augmented reality, and AI. So I'm going to start off with talking about what I do at the lab, and then Vivek will talk about his project at the lab. All right, so I am working on what's called volumetric capture. More specifically, it's an AI-based volumetric capture system. So I'm not sure if anyone here has heard of what volumetric capture is, but essentially it's a method of recording a 3D space using a bunch of cameras. And right now it's mostly used to record like people or humans doing some sort of like action and then creating a 3D model of them that can be used for like virtual reality or augmented reality or XR mixed reality applications. So what you see in front of you in that picture, that's like what a volumetric capture studio looks like right now in the industry. So usually, like you can see, it's a giant big facility. Usually there's like 30 to 100 cameras. There's green screens everywhere, and like the actors who are in the center will have to wear like motion capture suits. I don't know if anyone knows what that is. It's basically those like black suits that people wear with like the dots all over them. Yeah. So it is a very expensive and like heavy kind of like setup. I think I mentioned it's like usually millions of dollars to build and maintain. So what I'm working on is to kind of like scale that down to a very, very tiny fraction of that cost. So the studio we have in the lab is actually only 4 cameras. So, and the whole setup cost is only around $10,000, which is a tiny little amount compared to the industry standard. And I mentioned this earlier, but it's also driven by AI, and I'll get into more details on that later. And the goal of my project is to basically attain model quality as close as possible to the industry standards. So like what I showed you in the previous slide, the big companies like Amazon, Intel, Sony, they all have these studios.
We gotta change the camera to you. Yep. I don't know how to exit it.
Yeah, sorry. So yeah, basically that's the goal, and
Hide this. Yep. What's that? Okay. Sorry.
sorry again. So basically, and we wanted to make our studio kind of as easily accessible or easy to build as possible. So it only requires like a 10-foot by 10-foot space. So it's a very small footprint compared to like the previous slide. All right. So now I'll get into like how it works. So basically, as I mentioned, it's driven by AI. So first, I use this video capture software. It's called VCL 3D. Basically, this is what I use to kind of synchronize all 4 cameras and have them record simultaneously. It's also important for some other things which I'll get into later. And we use also 3 different deep learning models. So one is for background segmentation. So our lab does not have any green screens anywhere. So we use deep learning to kind of like do that for us. And then since we don't wear any motion capture suits to bring the cost down, I use another deep learning model to kind of like do that for us, also predict like what the human skeleton is, and then create a motion capture file from that. And then finally, to create the final 3D model is a technology or computer vision technique called NERF, or neural radiance fields, and I'll get into that in more detail as well. All right, so this is a software, VCL3D. Basically, it's like I mentioned, it's to record with all 4 cameras simultaneously, and it's also to synchronize for all the cameras. And what you see in the middle is, so the cameras I use are depth sensing cameras. So in the middle you see like the point cloud of what the depth sensors detect, and then to the right you see the output from the 4 different cameras. And this software is important too because once I do the recording, it also separates each video from each camera into frames, which I then use to kind of like train my neural network, my models. And another important thing that this software lets me do is it provides like camera calibration information, which is needed for the deep learning models going forward. All right, and then this is just this is a pre-trained deep learning model that I use to kind of just get rid of the background automatically. So this kind of replaces what a green screen would do without actually needing green screens. So if you see here, this is when I was like working at home in my basement. So this is me on the very left. It's like a still image from one of the cameras, and then run it through the neural network, and it actually kind of segments like my hands, my torso, hands, face, and everything. But most importantly, it got rid of the background, and then it also creates a grayscale mask to the very right, which is used for the input for creating the final 3D model. All right, so next here is it's called SMPL body parameters. So basically, it's another neural network or a deep learning model that produces like motion capture data. So since we're not wearing those motion capture suits, this model is able to kind of detect what you look like, where your joints are, and then output them into like a modeling software like in Blender. So in the top video, you see me just walking around in the lab, kind of doing a little test, and then underneath that is the output of what it detected after running it through the model. So this also is a pre-trained model that I use. And then finally, this is the most important part. This is like the NERF model. So this is actually to create the 3D model of the person, and they use the computer vision technique called neural radiance fields. So basically, a neural radiance field just uses deep learning to generate 3D scenes from 2D images. So right now, it'd be used to like map out like say like this lecture hall. So a person would come in, or like a drone would come in and just like take like 100 pictures of the lecture hall, and then use this technique to kind of create a 3D model that someone could like just like put like in like augmented reality. They can put on like or in virtual reality, they could like walk through the lecture hall. So I use that same technology to create a 3D model of a person, but it's a bit more complicated because the person is moving and it's not just a still object like a lecture hall, for example. So basically, this replaces the need of like the 100 cameras that I mentioned earlier, and so that brings down the cost a lot. So this is where we're at right now. So this is an example. This is a small 6-second capture of my boss, and I created a 3D model of him, and this is what it looks. So this is a 3D model that can be just replaced in virtual reality or augmented reality right now using my technology. So as you can see, it's not perfect. Like it's still quite blurry. Like we want to focus especially on the face like being more visible, because when someone is speaking, it's really important to see the facial expressions, and also it's easier to make out what they're saying. So that's basically what I'm working on. And now I'll have Vivek talk about his project.
So I'm working on a robotic arm project. So basically, you must have seen all these robotic arms in big factories such as Tesla factories or other big industrial industries. So there are a lot of different companies that actually want to democratize the use of robotic arms, and they want to increase the retail use for that. So there is one such company called U Factory, and they manufacture low-cost robotic arms. So it's called XM5. It has got 5 joints, and I'll explain what that means later. And then what they are actually, and it still costs $10,000, but still cheap by any other standards. And even if the cost were to come down, people won't adopt it, retail customers, because they don't have any expertise for hardware and software. So that's why that's where we come in. And what we're just trying to do, we are trying to build a intelligent and software a layer on top of it so that we could sell that as a package to the retail customers. So some of the applications that where we could use a robotic arm, it could be like a small manufacturing plant. So where a person at the end of the assembly line, they have to segregate between the good products from the bad products. So instead of that, if we use a robotic arm, it could automatically detect the bad product, go there and pick it up and pull it off the assembly line. Also in the case of like cellular agriculture, where you are growing the cells, plant cells in petri dishes, and someone has to manually remove those cell growth into different petri dishes and place them someplace around. So the reason we are trying to use robotic arm in these two particular scenarios and many more, so that the processes became scalable and you save time, money, and energy. So this is the one that I'm working with. So as I mentioned, like it has got 5 degrees of freedom. So it means like it has got 5 joints around which it can uh, rotate, and that's how it moves in the entire space. At the end of the arm, we have this Intel RealSense camera. So these are the same cameras that Bhagav is using in this project. So these are depth sensing cameras. So it not only tells like how big the object is, but also tells like how far the object is from the camera. So basically it acts as an eye for the hand. And then this is the gripper at the end, which will be used to pick up any object. So I have this small demo. So here we are trying to do it completely autonomously. Nobody is controlling the robotic arm, and so it sees. So what's happening under the hood? Basically, we are running the object detection model on the camera. It sees the object. It creates a bounding box around it, and those bounding box coordinates, like how much is the height and width, and how much is the distance from the camera. All those coordinates are with respect to the camera frame, but then they need to be translated to the gripper because gripper is going to do the picking. And lastly, how I'm going to use the path planning. So I'm using the sort framework called Robot Operating System. It's ROS, and it's pretty much industry-wide standard for development on open source robotics. So in this way, in my previous approach, like I was still trying to have to define like where actually the object is, and so some manual planning is still involved. But is there a way where we can actually automate the entire process where it recognizes automatically wherever in the frame the object is and it goes and picks it up? Yes, we can do it. And there's it's called reinforcement learning. So basically, it's a branch of an AI where actually mimics the human learning. So a top-down view is like there's an agent, in this case a robotic arm. It will interact with the environment. Environment is the whole surrounding around it. And instead of me telling the arm or trying to codify that how it will pick a particular object, because it's very difficult to do that when you're trying to write code for that or complex tasks like that. So I'm just going to say that define the task, and the task is going to be, okay, go and pick up the car. And so robotic arm or the agent will take some action, and on the basis of that, like the environment will say, okay, you took some action, did the action resulted in performing the task successfully? If the task is successful, then I'm going to define another thing, a reward function. So if the task is successful, and reward function could be as simple as you get +1 if you did the task correctly, But however, if you bump into something or you cause any accident, then you get -2. So that it reinforces that what is an accident and it reinforces good behavior. So I don't have to define the complex, how to write a complex task, but I'm just defining what my task is and what's my reward function. And we run this iteration a million times. So what happens, like it automates, and during the entire process, we are actually trying to maximize the overall reward, that overall cumulative reward that we're trying to uh, generate. So in this process, it actually learns like, okay, these are the steps I took, and then when I got a reward, and it actually learns that, okay, these are the steps are necessary to perform the task successfully. So this is, and I already talked about this, that this reinforcement learning, it very much used in robotics, and it actually helps us to like define the task and reward function. We can focus on these two without needing to hardcode or any other things, and it automatically learns the task by performing this iteration multiple times. So basically, we are doing this everything in simulation. So I have a demo for you for the next slide. So the reason for to do this in simulation is because when you're running something, you don't want any accidents to happen, and you don't want to wear out the joints for the robot. So what I've done here, like this is the same model, simulated model of the exam, and it's going. The aim is to go from the green position to the red position. I trained it for 100 epochs for around 2 hours. It took on my local machine with a GPU, and after that, every time it's always with 100% accuracy, it does the task, going from one place, point A to point B, going from red dot, green dot to the red dot. Yeah, and then and the benefit of training in simulation is that you can actually custom tailor your task. So it could be as simple as reaching from point A to point B, but could be as complex as how will you stack blocks on top of each other, or how would you grasp a very complex object. And then once you've trained your model to learn that task, then you can actually deploy them on your real world robot. So future work, like what I'm currently working on right now is, so in my first demo that I showed, it's just using, for object detection, it's using OpenCV techniques and I'm working on using the deep learning based object detection models because they're more robust and they give higher accuracy. And also, I'm trying to, the second part, like how I will use like reinforcement learning to make the robotic arm do complex tasks autonomously. So for this, I'm using a software platform from NVIDIA. It's called Isaac Sim. So a whole simulation platform end to end. You can create realistic simulation environments. You can train your model in that, robotic arm in that. And then you can, using sim to real, you can transfer your model, learn model from the simulation to the real world robot. So that's all I have. Any questions? And thank you for listening.
So that's our team right there.
Yes, I have a question on your talk. So you're using a real sense for depth sensing, I'm guessing, for getting the depth of the people and surroundings through the object mapping, right?
Yeah. So yeah.
So have you considered using, or like, is it in plan to use like normal commercial cameras and use SLAM to actually do that?
So actually, so I know I showed you guys the depth, like the point cloud, but funny enough, I'm not actually using the depth sensor part of the cameras because everything I'm doing is like just through the video output, the RGB output. So like normal volumetric video uses depth sensors, but not me because that's the goal in the future, to use commercial cameras. These RealSense cameras are limited by their resolution. So I want to eventually use like 4K cameras, so I can get well, first of all, better model accuracy, but also, yeah, just for that basically, actually.
Have you encountered any problems like rendering, like time to render?
Like, or like, can you explain?
Yeah, I'm just curious, like, so you're creating, essentially from cloud files, right? How do you render them, or like, is it, I came here like halfway through your thoughts. And
Oh,
I
okay.
don't understand.
Yeah, so as I mentioned earlier, I don't use point cloud files. I just use the video output. So when you record, it's like an MP4, and then then I convert them into like just PNGs. So each like it's like 30 frames per second. So each video gets cut up into frames, and then I just work on the frames individually. So I send in all the frames to like into the deep learning model, and then it outputs like what I need, and then then I put it all together into like I put it all together into the video after, like it stitches them all together. Yeah. So the only like real rendering is just like training the neural network, and that just takes a long time. But yeah.
Like, would you ever use the point cloud data in addition to the frames to render like shadows or other 3D effects on the person?
I'm not actually. So I'm trying to avoid using point cloud because I'm trying to not use what's being used in the industry right now because then in the end I'm just doing the same thing. I'm trying to make it a much easier, cheaper, and simpler solution so people don't have to go out buying depth cameras. You can just get a regular camera and get the same output. Yeah.
So do you have a path to like commercialization, or what are you thinking about getting this used?
Yeah, so the goal is to kind of like bring the cost of volumetric. Well, the main goal is to make it more accessible to content creators, developers. Because right now, if any company or anyone wants to create a 3D model of themselves or someone like an athlete or whatever, they have to go to these big studios and pay thousands of dollars for just like 15 seconds of footage. And so if we can like interrupt that and bring it down, like make it more accessible, that would be huge, especially considering how everything's like slowly moving to virtual reality and mixed reality nowadays. So
Would you try to open source it, or would you try to spin it into a company to like, continue to develop?
yeah, the hope is to spin it into a company eventually. Yeah. Any other questions?
Thanks a lot, Bhargav and Nick. Was an awesome talk, very inspiring one, I think. If people are like, I'm curious if students from UNC are interested in joining this lab, is there anything you'd like to share about the lab or something?
So we have like a lot of internship opportunities. So Natalie, she's our manager. You can go to our lab's website, and for the spring, you can look for the opportunity that you can even directly come by the lab, and also like we also host a regular open house. So tentatively, the open house for the spring is on February 3rd, but still not decided. But yeah, so if you want to just check out other projects in the lab and just talk to the students and people who are working, you're most welcome.
Excellent, great. Yeah, so here's the website, unzbluesky.com, if you guys are interested. All right, and now it is exactly time for lunch. So we have lunch outside. We have pizza and of course all the drinks and snacks. And we gather back at 1 p.m. for the next talk, which is going to be about deep speech. So, yeah.
So lunch would be held in room 265. To get there, it's gonna be on the opposite side of the building.
Glad to
So
see
if
you've got a
you follow
mouse,
some of our course
so that's
members,
good.
they'll need us
I'm gonna try to
to
link.
do that room. There will be pizza, drinks, and snacks. But it's all portion,
If that one works, that's actually what I use, a Logitech. I'm hoping I don't have to hold a mic in my hand. I'm gonna try to go back between two tabs.
So we also have this mic, and Andrew might help connect with this.
Okay, very good.
That's good. Shirts there. Well, I can't yesterday. Yeah, do you want to get these or do you want to do that? Well, we have.
Looks like it's not just outside. Yeah. Let me grab my stuff again.
It's people's fault. Yeah, so you can't. Yeah. So yeah, it's only.
Are you going over there? Yeah. Go with you.
I need to pack up my stuff.
Yeah, yeah, I'll wait for you. So are you working in Philadelphia or are you here?
So I work for a company here, it's in Raleigh,
Uh-huh,
but I work remotely from Philly.
okay,
But I'm gonna be back here next year, February.
very good.
They're
You-
calling everyone back to
Do
the
you want to bring,
office.
put it in a bag or you want to carry it?
My bag is.
Yeah. So that also is.
So you have college bathroom there?
But it's a conversation that
You can sit on it.
yeah, so it's a really cool.
So
Hopefully.
So the teacher must be behind that.
Yeah, exactly. Yeah.
And your students would be out here. Maybe you'd be talking to all your students in these chairs.
Today we'll be
And you
learning.
teach whatever you're teaching.
So basically that's like what
So that's no, that's what we are working on. It's all data something that we should have shown your audience already. Anything like in this yeah, I mean that's not now. With the one I have talked about. Yeah, that was also that's also here's one person speaking how individual is effective when it's not. Yeah.
So, Giovanni?
So what's your PhD? Right now, so, he said 265. And he said, bag and carry. There it is. Yeah.
Ouch.
Hey guys, you got it's a video once one. March. Yes, sir. This medium.
Yep, we got t-shirts.
This is small. Can we take one? For now, just take one at the end of the event. We'll probably have extras, so we can take some more.
Our small ones, did you say?
I think that one has the mediums. This one's just small, I think.
This is large.
Yeah, these are all smalls.
This is nice.
Do you have the shirts now?
Yeah. That's actually normal. Funny, yeah.
Smalls.
I got a medium here. Anyone need a medium? Anyone want a medium? Mediums? Anyone want a medium shirt?
So this is another.
What's that?
Oh, these are small.
You could put them over here. Are those larges?
Yes. These are all larges.
Oh, yeah, I have a small here. You need small?
This one is a 2X.
It's gonna be too big.
Thank you. Appreciate it.
2X.
Okay. Let's get one of.
You know, I think we can try to share.
Trying to get this forward. Thank you so
So
much.
we watching like 500.
I appreciate it. These are all larges too.
Nice.
This one is extra 2XL.
Are these all larges?
The largest, yes, those are large.
This is I think this is a.
Thank
2XL. Now, I wonder if it's an XL or a 2XL. Thank you.
Oh, okay.
That's why you stay. Not make it safe. Well, next year. Yeah. Oh, it's retirement, so you demonstrate a year.
Okay. So you want to use your own computer? Okay, so we have like HDMI. We might want to.
No, I have a school. No.
We will have to see how it will work.
Like, let's see if it is the same as ours. Okay. Yeah, okay. There should be something like laptop.
Yep.
Oh, extend.
Yep, I think I got it.
But then we'll have to stream as well, right? From your computer.
Yeah, how are you doing that?
How do we use this mic and still stream from your end?
So the mic will still.
Can we hook the mic into this?
So when you mean hook the mic,
Do you remember you did that when you were there? Like we connected the mic into your computer.
so what he did was the mic wasn't actually disconnected. We just had there was because my personal laptop was still the one streaming.
We can, like, if you like want to stream from here, we can stream from here.
I guess we could just get the backstage link.
Yeah, because backstage is a bit like
Yeah.
even
That's what I'm
OBS is
thinking. Like,
yeah, even
even if we
OBS.
do that, the only question I have is like,
What happens
we
to
use the mic. Yeah. I don't want to see echo.
we can mute the tab
Yeah.
here. Literally the whole tab. We can just mute it. Like, don't give it microphone permission at all.
Yeah, you can mute that tab and then stream the audio out of this, stream the video from this, and show this on the projector. Okay, yeah. Sounds good. But is that computer thing still on?
No, it's showing for mine.
Okay, that is still on. It will still show yours, but here you can control things. Okay. So you want to open the backstage link. Do you have a link to the backstage? In here?
Didn't get it either.
Let me send it to you.
Just send it. Anywhere, actually, WhatsApp link doesn't matter.
Some companies or that's half of it goes directly to them, not through some other process.
What's your WhatsApp number?
Say 469 438
No, I'm not an Apple.
2410.
My wife's still in it, but I extracted myself. I was an Apple guy
Last
for
one?
20 years.
Good. What? I think I have to add it as contact. Otherwise, it's not this.
They really should. So I tried searching for the next map. Five to $7,000 upgrade. Like, oh, so you have garbage Mac Minis, Mac Pros, and you got a thing. Screw you guys. I'm building my own sheet.
I need to find the backstage.
Oh, yeah.
Meanwhile, it's
I looked into it. It becomes your job now to maintain. It's like trying to, I don't want to insult you if you're a Linux and desktop guy, but I am not, because I don't have any patience for it. Well, okay, so if I did bracket,
oh, that is that basic.
Yeah.
From my own.
So we just mute it from here and use the audio.
But if you just do
so that works for you?
I don't like upgrading.
Okay. Now,
You need to open the backstage.
go back.
Just control V the link.
Oh,
Oh gosh, that was wild.
Did they just
Yeah.
should they get this at the end?
okay. Try it again.
Yeah.
I mean, okay, scratch that.
That's
I
easy.
say that, but I totally do get it. I just am very focused. I do driving sims, I'm driving sim right now. And I have a cyclist, it's like cycling sim, full time. So that technically is a game. Does it feel like a game to me? Because it's not like a yes, because those are the games I like, yes.
Well, I'm gonna do the question.
So hi all again. Hope you had a good lunch. We're now resuming with our events for today, talks for today. So now Rabimba is with us and he's gonna talk about his work on deep speech and how they got to a less than 10% error rate with this speech to text engine. So over to you.
Thank you, Ann. Hi, everyone. Good evening, good afternoon. Hope you all had a good lunch and feeling pretty sleepy. I'm going to make you more sleepy, or hopefully not. Let's see. Hi, today I'm here to talk about deep speech, which doesn't exist in this form anymore. It exists in a different form, which we are also going to talk about. We are going to talk about a lot of things about speech technology, how voice to text work, how speech to text work, what are the problems, go a little bit into math, and then go about into the more interesting stuff of how you can use it, how you can train in your own language, and some more things. So before we start, what is voice technology? How many of you have, in some way or other, have interacted with any kind of speech to text technology? Awesome. I should have expected all the hands. So those who has not raised your hand, you have never talked with Siri or Alexa or Google Assistant or to your car? So all those are examples of voice technologies. They all use speech to text to convert your speech to a text. Before we go forward, because this will be interesting, is anyone here who speaks more than one language? Nice. Have you found a good speech to text solution for your own language? I didn't. So I speak something, so I'm from India and I speak a language called Bengali, and I also speak a language called Hindi. When I look at my languages, I realize that there is no good speech to text available. And don't we want to have something where I can speak in my native language and it still converts it? Today, I'm going to show you how you can do it in your own language, how you can use transfer learning to actually use an existing model of speech to text and even get some amount of speech to text of your language going. If you have a community which contributes more data, you can have a good language built and contribute to the open source model as well. So going back to the slide, what is voice technology? If you see the robot, that's kind of like what we aim to be. So you are speaking with somebody, a tablet or something. So it's easier to work with text than speech. Machines had hard time understanding audio. So when we say audio, what they interpret is different, like zeros and ones, but mostly a spectrogram, like a wave. It's much easier to work on that. Instead of that, if you have a specific text, already libraries, we have plethora of work available on natural language recognition, natural language understanding, and natural language processing. So it's easier to work on text. With that in mind, when you see at that, the NLPROC, that part, I will say that the natural language processing, that's the brains. To get to there, we have to have two things. First, we have to take our speech, convert it to text, that goes to the robot. And then the robot, if there is a secondary, like bidirectional input to you, then we should have something where the robot should be able to speak, also text to speech. Even though that's not part of today's talk, I will at least tell you that how you can do that using the same language. Going forward, I hope this is legible. What we are going to talk about today, mostly this is the outline of the talk. I'm going to talk about a little bit about deep speech, the library Mozilla built, how the architecture works, why some of the decisions were made for specific model, how the language learning works, very little bit about the mathematical models, like why those were chosen, and then go a little bit forward about the future research problems, a little bit of demo, and also how you can use it today if you want to use it in your own application. That's a little bit about me. Those are my friends. That's I have wore different hats. Some of that in Mozilla, some in IBM. But see, my friends are cute. So let's dive in to the core architecture. So deep speech started as a Baidu paper, then a Google paper, and then Mozilla started picking up from that Baidu paper and started implementing it in a very different way. And we're going to talk about the core architecture, what deep speech is and what is there. So first, the architecture. So this, what you see in the slide, this is the core architecture of deep speech. Basically, it takes some input features, and then after that, we have 3 feed-forward layers and a little bit bidirectional recurrent neural network layer. We have another feed layer and a softmax layer along with the CTC layer on top of that I'm going to talk separately. So this is our input feature. When I go into the input feature, so I'm going to not go into the maths part too much, but let it to you like what you will need. So imagine if you want to take an audio, for example, this speech, like this talk I'm giving it, there are a couple of ways you can input your audio to this deep speech. First, if you see any documentation, you will see that they will tell you that you have to chunk the audio and you have to feed it. You can do a continuous audio, but if you chunk the audio, that has a better performance. Also, your audio has to be 16-bit mono audio. Why? This slide provides you the reason for why. So here we have an input speech. It's a 16-bit audio at 16 kilohertz. Anything other than that is not ideal for the architecture. How it works is that we take a little window, rolling window of 25 milliseconds each, and this rolling window moves after every 10 millisecond take. So the model actually runs in those. So another sample is to me that I can take another sample of these audio and take 25 milliseconds and create 26 of these Sestel coefficients. And we also use a stride of 2, which essentially means after every 2 of these, we skip one of these windows. That makes it much faster. And we have also seen that that gives us a similar performance for that. We're not going to go to the architecture, but this is the reason behind whenever you try to use it, whenever you see that, okay, you should chunk your audios, you should have it in 16 kilohertz. This is the architecture, and this is why they're told. Going to the feed-forward layers. So in terms of these 3 layers, they're actually, it's a really simple 3 or 4 layers width. Each of these layers has a width of 2048 bits, and they actually redo the cells. Once we have this feed-forward layers, it just takes the original audio and it passes through that. The bidirectional layer actually takes these, and we have, I can read the slide. Anyway, we have, we actually train these based on like a 248 layer widths, and this passes through that layer. The feed-forward layer takes on top of that and trains more on that. So if you have trained that, the reason for this is that can we give this layer a second chance? So this feed-forward layer takes whatever we have predicted and works on top of that. And then we have the softmax layer, and I didn't have the CTC layer slide. So what this layer and CTC does is that essentially it does the alignment correction in CTC. So when I am saying a sentence, and when you have your data corpora present, what happens is that you have your transcription, you have a sentence in text, you also have an audio along with that. Now, I can say a sentence very fast. I can say the same sentence pretty slow. So this alignment correction happens in the CTC layer. So going to the language model, this is what essentially happens for the loss function. I'm not going to the loss function explicitly here, because there were 3 versions of the loss function. Okay, I'll show that slide. That's in the backup slide. So essentially, we fixed in this loss function so that this provides us best performance for only English audio, and you can move forward with if you have a different language. So we are going to see a demo of how you can use this in a different language, and then I can show you that what parameter tunings you need to do. So what about performance? How good or bad this is? So this is kind of the performance you get out of it. What do these mean? Any of you have worked in speech technology before? So when you have something like WER, so what that essentially means is word error rate. How that's calculated is we have a golden data set where we already know that from a human transcription or something, that okay, this transcription already has these many words which are correct and these many words which are not correct. And we also calculate how many words are getting missed. When you pass that through any kind of speech-to-text algorithms, be that deep speech, be that Meta's algorithm, Meta's Google's algorithm, when you pass them through, we calculate the word error rate based on how many words are wrong or how many words have been missed. And based on that, we can calculate that, okay, is it performing good or bad? So what we have seen is that our word performance rate has become pretty good, 8.48%. So that means anything less than 10% is supposed to be in the range of human errors. This, however, take this number with a grain of salt, because almost most of the research work, they are based on specific audiobook data. For most of the academic research, that's a data source called LibriSpeech. So LibriSpeech is a data set where people have audiobooks read by professional readers, and most of these algorithms actually run through that to give their kind of baseline output that, okay, this is performing well or bad. When you are going to implement it, it's not going to be same. Your audio might have noise behind it. Your audio might have a speaker like me who has a pretty different accent from your training data set. So we need to account for that. Before that, let's talk about what future holds for us. So we can change the network variants of it. We can change the different CTC layers, the RNN layers, and the convolution layers, which is not present at this moment. And then how about the data? All this is good and fine enough, but how will you build your own language model? How will you even use it if you don't have a data set? So coming to Open Speech Corpora, so these are kind of the data sets this has been trained. So Open Speech Corpora is available part of LibriVox and VoxForge. This has a specific data set. You can use these. These are open source. You can use this to build your own model. Then Mozilla has built something called Project Common Voice. You can use Common Voice to come up with your own community. You can have GDSCs. You can have other people contribute your voice to this, and this is open to everybody. So you will see new papers coming up from every part of industry which cites Common Voice as their data source, because Common Voice is a platform where anybody just can go contribute their own language voice data, and anybody can use it because they are part of the open license. So how this mostly works is that you have a web page, you just go there, you record your voice, and you also read out specific things, so the transcription pairs are present, and these can be used for different purposes. There are options like you can have different set of volunteers who come and validate those speech, that are those correct or not, are those properly getting transcribed or not. So some of the future directions is that these can be changed. One of the big pushes right now is languages, because there has been plethora of work, and there has been work ongoing on improving the language models. But one of the prime barriers of it is getting those language data in it. For that, you need language data, so that's why Common Voice is there. Otherwise, there are Translators Without Borders who also contribute models in here. So a little bit of demo, this is how it works, and this is not interesting enough, so we will actually run it in Google Colab to see how it works right now. Before we go forward, let's take a step back and see what is the development life cycle of a voice. So till now, everything I've talked about, that's regarding the architecture and the meat of it. But I want to know, if I am developer, if I want to build a voice application, and I don't want to know about how these things are built. I have already these as libraries. I will just want to pip install. I just want to use it in my application. What are the good practices? How do I go about it? So if you see this diagram, this is how a life cycle of a voice application works. So you have model training, you have model QA, deployment, and everything else. The whole thing starts with your data collection. How do you collect your data? Does it have a continuous feedback loop? How do your data gets annotated? So for most of the developers who start on any of these, they already have a data model. They already have a model for specific language that they are gonna use. Once they're gonna use, then that's coming to a very interesting part, is that how do you do a quality assurance on these applications? How do we do a data QA on that? That part gets handled. That parts get handled in a very innovative way, because how do you do QA on a transcribed language? So you have to have specific native language speakers who can say that, okay, your data is performing as it should, or in an unpredictable way, because it's machine learning. Then you have to have a proper way to actually get new data in, so that your model performs as intended. Most of your audience is not going to be the same speakers how your initial inference model is. So you have to have a way to monitor them and training that. We don't have everything else, so we don't have a same shoe fit for all models. So you need to have a model so that it is catered to your own audience. So moving to Kokui, what is a Kokui? So Kokui is a frog, but the reason I'm talking about it is today is once deep speech model was developed, it went to version 0.9, then that team got dissolved from Mozilla. Now they're part of a separate open source organization called Kokui, that they're also a startup, but the same deep speech code resides in Kokui. You can use it. It's under MPL license, so it's a commercial friendly license, so anybody can use it. And the same models which was being deployed in deep speech right now gets deployed. It's the same code base, it just got renamed so that it can go out. I'm literally just going to show one slide regarding this, so you know what their websites are, how to contact that. So this is kind of their pitch, that they're developer-friendly speech solution. So they have a very good way to hack on those platforms, how you can build on top of that, how you can integrate your own language into that, so that you can actually keep building on that. Before we go to the pitfalls, let's actually see how you can, let me just, okay, sorry about that. Okay. So this is just an example of inference. If I want to do a very simple transcription on Kokui, and how you can do that.
So make sure it's streaming the right screen. You can select the entire screen. You can hide that.
So if you want to play with it, if you want to build that right now, I'll share this link, of course. But there are already like a lot of examples they have. So what you literally have to do is do a pip install. Here I wanted to get the really new one, so I did a wget. But you can literally do something like this, and it will install the HTTP client in your machine. So going forward, if I run it, I'm just going to run the whole thing and just going to go through with you. So literally what we're doing is just downloading their whole binaries, doing nothing else. And I'm going to get some audio files. This is an audio file I'm getting. And then I literally get a recognition model. So this is what we are using right now. This is an English large vocabulary model. There are other language models which we are going to see if it works, how we can do it. We're getting LibSocs for processing that. And this is where you are getting your speech-to-text client built. And this is just from the same source code we just did. Once we ran it, this is running the tool, and yeah. So this is the transcription. So essentially, if you want to play with it, you can literally just do a pip install, and then you can literally, so you should download this model. This model, there's a model zoo from where you can download your specific language model. I just did it for English. So you just download your English language model. It's a TensorFlow Lite model. So you just download the model. You have an option to add a scorer, but that's an optional. You don't need it. Once you download the model, you just point it to your audio and you will get your transcription. So all those things I talked about, that how you like feed it to specific chunks of audio, the specific mono audio and everything, that gets handled. This audio is already mono, so this doesn't have to be, like, you don't have to do anything. But the SOX library we used here, you can use this to read the audio, or you can use a FFmpeg to actually change it to the required format, or even chunk it out and do that. Now, if I want to build this for a different language, so this is how you can do a transfer learning on an existing language model. So, for example, if I want to do it in a Bengali, what would I do? This is for Russian. I thought that would be more interesting. So this is literally, I'm getting a pre-trained English model, the same vocabulary model we used, and we download the Russian data language, the small data set we have, the transcription language, and then can fine-tune the English model using the Russian language, and then see how it performs. So when I run it, what it is doing. So first, the same thing, we're going to install the training data set. And if you want to do it, literally what you have to do, these are all pip installs. You don't have to clone it, you don't have to make it, you can do it, but you don't have to, unless you want to like live on the bleeding edge. Then we are gonna get the pre-trained English model. So that's literally from here, this model zoo. So we are just, no, not in my machine, but anyway. So from here, you could just download that. And then once we have it, we can download the Russian data models. This is this WAV file, this CSV, this alphabet. This literally is your different data, that you have a voice and you have the paired up transcriptions, and the alphabet is your language model alphabets. Once you have it, this is all you need to do the training. So we are getting using the checkpoint data that is already available in the existing model, and we are just pointing it to the training files, this Russian files and alphabets. Once it runs, here we are actually gonna use the training part. Once this is done, this should be done in reasonable amount of time. Probably should have run this before the other thing. I assure you, this didn't take this much time today morning, but live demos always fail. Yeah, it finished. In 46 seconds, that's not bad. Okay, so this is what we got. So I just ran a test set from here. So we have existing testing data set which we can run to literally see how good or bad it performs using the same word that I told you about. So this is what we got. This is not good, not bad. Like, I mean, the word it looks pathetic. But anyway, so if you look at the loss and everything, but the point is, I just used a very small data set. I just ran something out of it. It was able to give me something. I don't know Russian, so I don't know how good or bad this is. Probably bad, because this was the source and this is the result. You will see there are words missing. But you will also see it got a lot of them right. So this is more or less, maybe not more or less, but anyway. So this is how you can actually train it your own language. And I just did it in a Google Colab, no fancy thing, nothing, and just use it a very small data set within 43 seconds. So if you know a second language, if you are interested about it, you probably want to try it and just give it a go, see how good or bad it performs. And if you have a good community who is interested in donating their voice data to Common Voice or even to your own purposes, you can actually train that. Once you're done training that, what you're going to do with it? I mean, you can of course keep it to yourself, but I would suggest contribute it here. This is the models view. Here you have existing trained languages for every other, not every language, a lot of language. So for example, when I didn't find anything in Bengali, if I try to find something, there is a Bengali STT contributed by Alp. Alp is part of Translators Without Borders. So, and how he did it, like this can be like completely separate them altogether because Bengali has literally very less amount of voice data. So Google has an open speech data from Bengali. So he used that to train. Now comes the interesting part. This one, even though this is Bengali, it will fail pretty bad in my language, like when I'm gonna speak. The reason is Bengali has, in phonetically, it has two language codes. So whenever we talk about English, it's EN and the language code. Bengali, it is BNIN and BNBB. So Bengali is spoken in two countries, in India and also in Bangladesh, and we have very different dialects and pronunciations and also words. Most of the data which comes to the open source speech corpora from Google, that's donated from volunteers from Bangladesh community. So that doesn't perform that well to mine. So what can I do? How Alp actually did it is that he took that, he did the same transfer learning I just showed to you in a bigger scale, and he was able to do the training in 24 hours. Now, if I have enough volunteers from the similar locality I am from, I can actually improve on the same data set to have it recognize our dialects and pronunciations better. This applies to your audience as well. Whenever you're going to build your own voice solution, it's not one shoe-fit-all solution. The same English, like the same thing we just did here, and it worked perfectly well on this audio. This will probably not work well at all in my case. So when you're going to build that solution, you have to keep that in mind. And what is my... With that, we are almost at the end, and the common pitfalls you probably generally face. Don't assume a common size fits all purpose, because the same English we saw, if you put somebody from Scotland, from Wales even, it's gonna fail pretty miserably on that. Know your models. Your models, so your data is as good as, your transcription is as good as your data. For example, you are doing something for a new language or something else, and you have only have volunteers who are from age 40 to 50 and only males. In that case, there is a very good chance that your portal might not perform that well for females of maybe 20 to 30 or even less or whatever. So know your audience, know your data, and keep on working on that so that it doesn't get lopsided. So when you're working on any industry solutions, voice technology must be part of your whole life cycle. It has to be an iterative, creative process. It doesn't have to be just I have a model, I'm just running all through it. You should have a process of online learning where the transcriptions you are getting, where the transcriptions suggestions you are getting should be always iterative, and that feedback loops back to your project. Case in mind, there is a company called Fireflies AI which builds voice transcriptions for your meeting notes. They have a way of how your customers' feedbacks loop back into their model, and most of the companies do that. In natural language processing and voice teams must work together, because a lot of the challenges I told you about the data collection and everything NLP teams can alleviate some of your problems. They can do clever tricks to actually like make your life much easier. So you probably should work with them, not like work in silos. Also know your data. This is the really hard part, but you really have to have a way of listening to your data. This is not scalable at all. But when you are working with small language models or minority language models or really niche language models, you have to actually have a human in loop, actually listen to the transcriptions and see that, okay, where it's going wrong, which words is going wrong, is there a way to actually incorporate that specifically even word-wise in your model? And what are you measuring? Are you measuring your model properly? Like I said, word error rate is one of the like industry standards, but how it is done in industry is literally compare it to an audiobook that has a very specific speaker base who speaks in a very professional way in a noise-free environment. That probably is not your audience who is working maybe from a Zoom call or has a dog barking in the background. So you have to measure your own data, not from just like audiobooks. Define your use case. So see how your model works, see what kind of data you need to work on. If you have a studio environment, you are getting really good quality data. Do you want to downgrade the data to work on a like a model which was trained in a different way? So why not upgrade your model to use that data? Remember, when you are working with a team, every part of it is part of that team. So if your text model breaks, your NLP also breaks because it is getting wrong data. If your text model is working fine, then the NLP team is getting good quality data, and they, whatever inference they're making, whatever logic they're putting into it, that has more value instead of, so it's like literally garbage in, garbage out. With that, I'd like to open up for question. If you have any question, I would be happy to take it. Thank you. So that was mostly to kind of give it a second chance to guess the words, because when we used it for the first time, it wasn't performant enough for all kind of audios. So we used multiple datasets, including an closed source dataset for the initial training part, and we realized it works very well for all of those datasets. The moment we go outside, like our own engineers, they fail. So we try to see, like, try with the concept that how can we give the guesser like a second chance of guessing those words. So the same part, do it forward. So that was the main reason. This architecture has changed right now a little bit in Kokui. This was the original deep speech architecture prior to 0.9. Now it is changed, it's way more performant, but yeah, that the main basics still remains same. Yeah.
Are there any plans to extend it to non-alphabetic languages, where like Chinese, for example, where like one sound doesn't equal one character?
It is, and I know we have Chinese traditional language models. I never put it inside the talk because that model itself is closed source. So, like, I cannot show you even if it works. And second is that is like a there is work going on, but that architecture is different from this. So it's a little bit going in a different way. But yeah, there is work going on in that. And I think I can point you to a demo which works in that. You will be able to run it. You will be able to get the model to run it your own, just that you will not get the source of those models. Anybody else? Thank you. Thank you. So that's me after every talk.
So thanks a lot, everyone. And now we'll be moving on to the next talk, which is tech entrepreneurship with Chris. So please welcome Chris Esplin from calligraphy.org, and he's also working with another startup, boombot.com. Please welcome Chris for the next talk.
This is going to be exciting. Okay, so Mike, all right, in hand. I am not planning on using any slides. This is going to be interesting.
I
Okay,
think then we should be good.
we should be good to go? All right, cool. Also, I'd like this to be a bit more of a discussion, hopefully, than just a pure me spitting words out into the ether. Because, you know, we've talked about all these really sort of very technical things. This talk is not going to be technical at all. This talk is 100% dealing with real life and dealing with failure and the roller coaster that is trying to run businesses, which we all inevitably become part of because it's really hard to make money without building a business. So, all right, first, advice is kind of dangerous. So I'm going to be really tempted to give you a ton of advice, and I'm probably going to be giving you some advice. But we should be really careful about that because there are a couple different ways that advice goes wrong. First off, sometimes I have a very specific experience that doesn't apply broadly to everybody else. Right? So I may have something that works great for me, doesn't work for you. It's the first kind of failure. The second kind of failure is sometimes things work great for the world at large. Like a lot of studies on like health will say, hey, this kind of diet works best. It works better than this other kind of diet. But I'm a single individual, right? I'm a single data point. So some things are going to work for me individually from everyone else. So we're all special in that sense. We're all going to be a little bit unique. And so my unique advice doesn't really always translate well to everybody else. Okay, so I'm going to start with my story real quick. Why I have any background in this at all. I originally studied finance and economics, so I was not a programmer. I had this whole plan of I graduated from Brigham Young University in 2007, went off and tried to start a career, and it did not work very well. So that was my first really big failure that I had. It was my whole college plan kind of face planted. And that was a huge loss. At the same time, I tried to start a zipper purse business. This is this crazy thing that happened that I did in college. Total failure. Sold about 5 of them. After losing my first job out of college, I started scorpionsurvival.com. It's kind of an embarrassing website. I was drop shipping stuff all over the country. I made about $50,000, but that was revenue. There was no profit. I probably lost money on the project. After I became a software developer, I did a lot of freelancing and consulting. And that kind of worked, but it turns out you need a lot of business to make that really, really work well. You need a lot of incoming clients, and I could never keep enough incoming clients. Eventually that one failed too. I got fired from my very first developer job. I joined a company that was kind of a little sketchy. They were doing some fraudulent stuff, but they hired me, and this is my first self-taught developer. So I was super excited about it. But they fired me about 5 months in, then promptly went out of business. I built a lot of web applications, and they've almost all been failures. They're all over. I've got my website, chrisesplin.com. You can go see a whole list of all of the stuff I've built, and most of it hasn't worked very well. I tried to build a business around Firebase and became a bit of an influencer on Firebase online. And that's kind of what brought me to this point, because I got an association with Google through that. And that has been awesome. But as far as building a business on top of it and feeding my consulting, utter failure. Couldn't really make any money. I think I made like $1,000 over the course of a year off of that business. So that was really frustrating. And some of it's kind of embarrassing. We don't talk a lot about our mistakes and how we have so many of them, usually throughout our lives. But you really have to be comfortable with that in entrepreneurship, because you're going to fail more than you're going to succeed.
So let's talk about some of the things I have done that have been more successful. So I did really well in university. I graduated magna cum laude, double major, worked really hard on that. I did teach myself how to code from scratch. So that was another pretty big success. My third big success career-wise was calligraphy.org, which is a business I started with my wife, where she teaches calligraphy, and I built her an online platform to teach calligraphy on, and she's been teaching for years. It's been going for over a decade now. I was full-time on it for about 4 years. And that was fantastic. I really loved that. That was sort of the promised land for me. And now, after that business took a bit of a dive, I now work for a company called boompop.com, where we do event planning for big companies. And that's actually going really well, and it's part of a bigger startup. So it's a VC-backed, full-blown, legitimate startup, not a bootstrapped business like I did with my wife. Okay, so that's a little introduction about me. Has anyone here thought about starting a business?
I've tried a lot of app businesses that hasn't really worked out.
Yeah?
So I just stick to freelancing that kind of pays the bills. But lately, I've been having trouble getting clients, so I'm thinking about doing something again.
So you're going through the same thing I went through, and you've done it too?
I'm trying, we have an LLC, we're starting marketing.
Nice.
But I've coded like 14,000 lines of code, and that's it.
Yes, I do the same thing. I've built a ton of these things. Yeah, okay. That feels very, very familiar. Because I love coding, right? So I'm going to code. But then when it comes time to market it and sell it, I don't love marketing or selling at all. So I've discovered I am not a triple threat developer. I can code, but biz dev and marketing, no. I'm very bad at marketing. And so that self-knowledge of recognizing where you're strong and where you're weak is critical. Otherwise, you just go in like I've done so many times, and hey, I'm going to do everything for this business. I'm going to be the business. And then you realize, no, I'm good at one part of this business. This business needs 3, 4, 5 different people who are good at these 5 different parts. That's why I work for a full startup now with staff, with marketers who are incredible. And every time I see what they put out, I go, wow, I'm so glad I get to work with you. I don't have to try to do that. So that's cool. I'm glad I'm not the only one. Awesome. So my next point is about chasing losses. And when you make mistakes like I tend to make, when the freelancing starts to dry up, or I mean whether or not you get your business off the ground and get it, it's so much fun, especially at first, right? You get so excited about it. You want to do this, and you can see all the possibilities for how this is going to go so well. And maybe it will. You know, I've had a few that have gone well, but a lot of times it doesn't. And the skill there is understanding the difference between a doomed project and a project that's just in the trough of sorrow, as they call it in Y Combinator. Because every project has the excitement and then the trough of sorrow. And that can last for a long time. I mean, it could be years. If you guys ever use Figma? Familiar with Figma? Okay. You know, Figma just sold to Adobe for $20 billion, which is absurd. Like, absurd amount of money. Do you guys have any idea how long Figma was in, like, incubation? Figma's been around a long time, guys. It was a long time. And they didn't have any users for the first 5 years. For years, they were just working on the product, making it better. Finally, they got it good. They released it fully after a few years, and it started taking off. But their trough of sorrow lasted for years. And that's not uncommon. And we all try to limit that as much as possible, but it's not uncommon. So knowing the difference between, hey, this business is absolutely doomed, which is most of our businesses, and this business could be very successful, but it's in that trough. That's just something you have to build up an understanding for that, for yourself, because you got to make that decision. Do I give up on this, or do I try to stick it out? And when I say don't chase losses, this is a really critical concept just in life in general. I think about it in terms of poker. I don't play poker. I don't gamble, but I love watching poker on YouTube. It's really fun to watch people play poker and gamble because they do a really good job of it. And there are these two kinds of things in poker. There's the epic call, the hero call, and the epic laydown. There's when you have a terrible hand, but the other guy's got a worse hand, and you call him anyway, and you win with a bad hand. And then there's the opposite of that, which is you have an incredible hand, but the other guy's got the best hand. And you have the instinct to lay down an incredible hand. And that's really the hardest, laying down an incredible hand, and you've got it. And that epic laydown is the ability to not chase your losses and not get suckered by something that looks really good on the surface. That's knowing when to quit. And knowing when to quit when you feel like you're winning is really, really hard. Extremely rare. Okay. So my next point is entrepreneurship is really a faith-based activity. You're doing something that feels, you can get really excited about it, but it may or may not be real, and you have to have a belief in your soul that it's real and that it's going to work. And if you don't have that belief, you're going to get knocked off. You're going to get pushed off the business, off the project. You're going to quit early. You're going to hit that trough, and you're going to get discouraged because you don't have enough faith in it, enough strong belief in it. You're going to get knocked off it, and you're going to quit early. And I've definitely gotten knocked off of a lot of projects where I just lost faith in it and had to quit. I just couldn't do it anymore. So you have to be very aware of your belief. Do you have a strong sense this is really going to work? Do you believe it in your core? If you believe it enough, you'll be able to make it through. If you don't have a strong enough belief in it, you'll fall off it. And of course, like I just said, don't chase your losses. The caveat to that is I've seen people work for a decade on a project that wasn't going anywhere. They had such a strong belief that was delusional. And that belief sort of turned into a delusion that this is going to work. And this guy tried to contact me to do some contracting with him. I was trying to help him out. And I realized, oh, shoot, how long have you been working on this business? Oh, about 9 years. Like, oh, this is all the progress you made, really? Shoot. This is rough. And so I was able to get myself out of that and not work with him. But he hadn't made any progress in years, but he was still going for it. So you have to know when to get off of that losing situation, how to run away. Okay. Okay. So you were talking earlier, it sounded like it was like a bootstrap business, right? Thinking about bootstrapping a business. Okay. Have you guys ever thought about raising funding?
Once we have proven the concept, then maybe we'll consider it. But when you're still experimenting, trying to validate the market, I find it's a lot better to bootstrap.
Yeah.
So that's how.
Okay, cool. I came, yeah?
I was gonna say, the way I raised funding for the only business that I ever started was, I did an entrepreneurship competition, but it was for a different business idea that I knew would appeal to the judges more. And I raised money. So that was like my sort of like work group.
Awesome. But did you when you won that, when you got that money though, were they like investors or were they?
It was like a university competition, and there was like some people from an incubator, like judges, and it was like prize money.
Okay, so it was more of a prize than a. All right, that's cool.
Yeah, Google actually has they call it the Google pitch competition. You're just like kind of similar, but like this year.
Yeah, that sounds really cool. I like that a lot. That's a good model because now you're not beholden to somebody else. They don't own you. Yeah.
So I'm a software developer and I am here in the US as a student, so I can't really do a startup. But I had a friend who wanted to start a company here in Japan, and they actually did it. It's called Samosa Bucket. They had to move to DC, so they had to close it down. But it did get profitable, and it was basically him delivering samosas to people through this modern stack web app that we created. And it was the advantage over Uber Eats or everything was that they didn't charge anything for the deliveries because people had to schedule those 1 week in advance.
That's
So
awesome.
it was more like the FedEx for food.
Yeah.
And it was working.
That's really cool, but they had to shut it down.
Because he moved to DC, and he used to do that to just kind of get some side income while in college. Now we both graduated, so.
All right. That's awesome. That's great. But that's a lot of hustle.
Yeah, and about the grants and stuff, so he used that app and showed it to launch Chapel Hill. So they have a cohort every summer here in Chapel Hill. So he got into that cohort and it gave him $5,000 funding for that.
That's really fun.
Oh, there's a lunch Chapel Hill. Okay.
Yeah, there's
I gotta check that out.
That's great. No, that's fun. There's a lot of hustle. And that's really what entrepreneurship is, right? It's hustle. It's just working like crazy, making something out of nothing, and just praying that it actually sticks. Yeah.
Yeah, kind of in a similar situation. Like I started a couple companies, bootstrap most of them. I had a company in college that got offered funding like 50K.
Nice.
So I've kind of been. I did like 2 years at I'm from Charlotte.
Okay.
There's an organization called the Charlotte Angel Fund. I used to help the fund manager there for 2 years. I was like his assistant, so I learned a lot about deal flow and like the amount of energy it takes to fundraise. And I realized that it would take me the same amount of time, like 18 months or even more, to fundraise $1 million. And I could spend those 18 months making $1 million.
Yep.
Just selling something,
Yeah.
So I guess that's something to consider is like when you go on the fundraising path, depending on where you are, it can be very hard to get people to say yes.
Yes. Fundraising is tough.
Charlotte Angel Fund. Okay.
Yeah. Yeah. No, that's a really common situation.
Yeah. So and that's the thing, like I will bootstrap business, but in some cases you might require capital.
Yeah.
So it depends, right?
Bootstrapping is awesome. A lot of businesses bootstrap. Like MailChimp was bootstrapped. Like it sold, I think, for like how many billions? Many billions of dollars. Like Intuit, I think, recently.
And one last thing I add, guys. I'm sorry.
No, go for it, man.
But like with bootstrapping, like sometimes I feel like because I'm from UNC Charlotte, I do a lot of stuff and I'm student entrepreneurship there. Is that you shouldn't look down on traditional businesses because you can make money in a traditional way, like delivering food, and put that money to work in your technology, or something else. To be able to bootstrap your own stuff as opposed to asking people.
I mean, there are a lot of very profitable restaurants out there, for instance. A lot of failing ones, a lot of really profitable restaurants. A lot of really profitable like oil change shops. A lot of ways to make money in the world, right? But VCs, venture capitalists, only want home runs, right? They want billion-dollar businesses. They don't want you to have a middle of the road business. Like they don't want a business that makes you. Let's say you had a business idea that made you $2 million a year. You know VC will ever fund that. But they're not interested in that. They want 100 million in revenue every year. That's all they care about. And so your scale would be wrong. It'd be awesome scale for you, but a terrible scale for VCs, right? So there's this whole world of bootstrapping that we don't talk about a whole lot, but is really can be really valuable, and is where a lot of the best business ideas actually really come in. Let's see here. All right. Okay, so I've got another point along these lines, especially with bootstrapping. A lot of overnight successes that you see in the world have been decades in the making. And that's a really important concept that if you've been involved in this, you figure it out pretty quick. Like, so my wife and I launched calligraphy.org in 2012, and I was able to quit my job and go full-time on it in 2013. It took a year to go full-time from launching the business. She'd been teaching calligraphy for like 8 years before that. So she'd been teaching for years, and I'd been learning how to program, and we were making all this progress, and eventually we launched the business. But there's no get rich quick in this world. Like, it's get rich through a lot of work, and maybe it looks quick in the end, but it wasn't quick. It was a lot of work. And also, anything that looks too easy is probably a scam. So, That's just odd, like general advice, but most of the time things that are too easy are scams. So you end up having to have done quite a bit of work. Okay. Let's see how much time we got here. All right. We got plenty of time, so we can talk about all sorts of fun stuff. Yeah. As far as my experience goes, I launched calligraphy.org with my wife, and after many years of her teaching calligraphy, I learned how to code, launched the business. We were making really good money for a few years. It was really awesome. And I sort of tasted of that fruit. I experienced this lifestyle where the workload was really low, but the income was really high, and I had a good time. I really partied for about 3 years. And I want to get back there so badly, and I don't know how. I've been trying to get back there for ever since 2017 when I had to quit and go back to the regular workforce. Been trying to get back there. And I probably will never stop, but I think it may take me years, maybe decades before I get back there again. It's a really common pattern to get lucky and think that luck was somehow you that created it, but it was really the luck. It was really the timing, the situation was just right. And so you'll see that a lot in other people too, because you only see the winners, right? You don't see all the losing ideas out there. You see the winners. And a lot of those winners got really lucky. There was I've just seen businesses. You see this a lot with entrepreneurs that have a really big first company, like a $1 billion exit. And then they think they've got the hot hand, and they go in for their second company. They think they're going for another one. They're going to go even bigger the second time. And the second time is just, a rough failure. Because they didn't realize how much the luck had to do with that huge outcome. They internalized that outcome is their outcome. I'm the reason that was successful. Well, yeah, you were, partially, but your timing matters so much. So never underestimate how much that timing matters. And don't be afraid of that grind, because sometimes the grind just has to happen. Yeah. Okay. I don't have a whole lot more material here, but I wanted to talk about I want to talk a little bit about like a philosophical component to this, which is it's kind of like a self-knowledge, like introspection thing, where you have to understand what motivates you. You really have to figure this out. This is critical, even if you're not doing entrepreneurship. And for most of us, entrepreneurship isn't the right answer. Let's be straight. Most people should probably work at a bigger company. If you have to understand whether you really, really want it badly enough to go out and just hustle this yourself. But you also need to understand your own internal drives. Like, what drives you? Is it money? Is it attention, fame? Is it, for me, I've always wanted like recognition. I don't think I got a whole lot of recognition for some of the stuff I did when I was a kid, and I felt sort of like underappreciated. And I've always wanted it. And it's kind of, it kind of pops up, and I find myself doing stupid things sometimes, searching for recognition. And it's like, oh man, that was dumb. And I fall asleep at night the next day, like that night. Oh man, why did I fool myself, right? So I think you really need to understand yourself and what you really, really want, because not everybody wants this, and you have to find a way to find out what you really want and let that drive your decisions. Let that be the engine that pushes you forward in the entrepreneurship, in the business. Because you really have to be true to that, to your inner desires. Otherwise, you're trying to fake it. You're trying to fill in gaps that aren't really filled in. You're trying to be someone you're not, right? You got to be who you are. It's really hard to be someone you're not. That's why we hire other people. That's why we form teams. That's why VCs fund startups, because you get a team of people together that fill in all those gaps. You can be incredibly successful. The startup I'm working at right now, our team is incredible. Like I work there because of the team. The team is excellent. We've got incredible marketing, incredible leadership, incredible development. Everything is just really good, and it just feels great to work as part of a whole cohesive team. So, yeah. Anyway, that's sort of my experience, and I'd love to open it up to any questions, any comments. Hopefully I've spurred some thoughts. Yeah.
You were talking about earlier
Yeah. Okay, here's a really good one. So the business I'm working on right now, the startup, we originally were doing virtual events. So we had ads running on Google, and executive assistants or executives would be like, hey, my team's working remotely. I want to get them together for some sort of a party. How do I do that over Zoom? And so we'd have these events, like a magician would show up over Zoom and do a magic show over Zoom. And these things are like a little trend, like 2020, 2021. And we hopped on this trend. And we became the biggest virtual events provider on the internet. You wanted the virtual event, you found us through our Google ads, through referrals, and you hired through us. And we had hundreds and hundreds of different events you could purchase. And so we're super excited. We're doing millions of dollars in revenue. And one day, I get a message from our marketing director. She's like, hey, Chris, I think you got a problem with the tracking on the site. What are you talking about? When it comes to tracking strategy. Like, no, I think you have a problem with tracking. Our numbers are down. Like, you sure about that? So I double check it, and yeah, tracking was good. She's like, I keep looking. He does more and more research and discovers that the price of our ads is going up and the productivity of our ads is going down. There's a bunch of companies trying to get into this space, but no one was searching for it anymore because it was going out of style. And so our business, when she brought this up to the CEO was like, well, shoot, we're not doing this business anymore. You made a call. Like we had this $10 million run rate or something like that, and we just, nope, we're gonna pivot. And like that was leadership. Like the ability to make that pivot on this, this one data point. Yeah.
I have a question.
Yeah.
Talk to me a little bit more about how you go about like finding good people to work with and separating the real, genuine people from the fakers. That's something I've struggled with in the past. So I'd love your opinion on that.
I think okay. So the question is how do you find good people to work with and how do
you figure out if they're real or fake? Like I've had some people, after that first day and after the sex was great, we're gonna change the world, and then when you get down to the work, I want 50% up front. Anything else here?
Yeah.
So it's like, how do you
find the right people to work with and evaluate them?
Yes.
Yeah, that's something you get better with over time. That's really what the art is. You ask them a lot of questions, have a lot of talks with them, try to get them to open up to you, get off their pitch, because they got a pitch for you, right? Like they're going to sell you with their pitch. You've got to get them off the pitch. You've got to have a conversation with them that drags them off the pitch. You've got to somehow, if you can see them in person, I don't know. You kind of have to figure out what works for you, but you've got to find a way to get more information. And then the moment you get that hint that they're not playing straight with you or they're not going to be the person you think they're going to be, know how to get out. You really have to get out sometimes, and it's ugly. I've only been actually cheated once. It was only it was one contract. It was a small contract. It was like $1,500. Still hurt. I still remember it. Yeah, I'll never forget her. She was really rude. She just disappeared one day. I never paid her bill. The hint on that would have been that she delayed she started delaying her bills a little bit and just delaying. And that was the only hint I got. But it didn't get that far, right? I didn't let it go too far. After we hit about $1,500 on her tab, I was like, I think we're past the spot I'm comfortable with. You're gonna have to pay me up or I'm not doing another line. And that's when she disappeared. So a lot of with the freelancing, a lot of it is if you don't make them pay up front, you can make them pay 50% up front or go in really small chunks. So small chunks helps a lot. So that you're limited by the size of that chunk, the biggest loss to take.
Yeah, but what about in terms of business partners, for example? Yeah, that's where we were working on this little kind of like bringing bring online shopping local. That was the idea we thought. It sounded great. He was like, I'm gonna do the marketing. I was gonna do the tech. And then it's like one day, yeah, I want 50% upfront. Like, and that was just, we didn't even work. He sounded good at first. It sounded like he had a lot of contacts, but then when we got down to actually doing it, he just flat out said, I wasn't gonna do anything until
Yeah.
you give me a 50%, and you've been working for months already. So it's like,
That's not
yeah,
uncommon.
like how could have actually figured that out faster?
I don't know. I think the only way I found is to move up market. So as far as consulting goes, bill more. If you bill more on consulting, you'll find a higher client. More people will say no, but when they say yes, they don't care about the money. They just want the work done, right? So at first I was like, oh, $30 an hour, that's my rate. And then I just got all these sort of really rough clients that were like really tight on cash and like didn't want to pay me at all, but they could stomach 30 an hour. Then eventually I got it to like 100 an hour. And then most people would say no, but every once in a while someone would say yes, and they'd be, oh yeah, sure, no problem. And so now I'm trying to move north of that. I need to be to try to work with even higher end clients. So a lot of that is just moving up the tree. Yeah, but it takes time, it takes a lot of work, and it's not something you can skip to the end on, unfortunately. Sorry.
Okay.
No.
How would you recommend getting the word out about something that you've developed? Sometimes it can feel like pulling teeth, trying to get people to talk about it.
Yeah, that's marketing. Yeah, you discovered the thing that I hate most of all, and it sounds like you might hate it too. I know people. I've worked with good marketers who can do that, and it's like magic. I don't understand how they do it. Like a good marketer can just talk about something all day long, go run ads, is like super involved in this, and like that's what they like. I like coding. I don't like doing that. So for me, I just avoided it. My wife is a bit of a social media influencer, and that's how we got her first business off the ground. She did all the marketing for it. That's why it worked. Customers would just come. They'd show up on the website. I tried writing the ads, didn't work. None of my ads ever worked. But her social media game did great. I can't post like her. I can't be a social media influencer. So no, I don't have anything good for you there. I mean, if you want to do it, you have to commit to becoming a marketer. So.
What are you building the podcast?
We're building an online tutoring website. That instead of being a traditional tutoring firm, anyone can register on Uber and set up anything they want.
Yeah, this is a website called ProductCon.
What?
This is a website called ProductCon. Like a lot of people will build stuff, post stuff on there. There's a lot of investors as well there, so if you want to.
Yeah, Product Hunt?
Yeah.
ProductHunt.com is pretty popular.
I think I've heard of that, yeah.
Yeah.
So like, try posting your website there.
Well, so what you're building is called a two-sided marketplace.
Two-sided market. Oh yeah, it's sort of a platform where money comes in for one group of people and money goes out. Yeah. And we're just doing like a flat rate, 5% fee.
Exactly.
But it's sort of, I think the difference is that there's like this online collaboration suite. So that's not like you have to find all these really difficult ways of trying to write something down or share a document.
Yeah, so you're building a two-sided marketplace, which is exactly what the startup I'm at now, our regional virtual event business was a two-sided marketplace. Airbnb is like one of the best examples, right? Uber, those sorts of things are two-sided marketplaces. There are written about how to build two-sided marketplaces. It is a very well understood system. I would do a lot of research on two-sided marketplaces and the dynamics of how those things grow. They're very specific. There are very specific ways to be successful with that. And if you don't do it right, you're going to run into business problems well before your software becomes a problem.
One of my biggest concerns was that the profit margins seem so low because oftentimes you're forced to take a cut, but you really can't make that too high, otherwise people will switch to other solutions.
That is a fact. That is a big problem. That's one of the things that was dooming our virtual events business was the cut we could take. It started out high, and over time we realized we had to get it lower. And we eventually found the right one. It was like 10% or something. But it just wasn't enough. And you have to do a ton of volume on a marketplace like that. A ton of volume. Yeah. So it's really crushing. A lot, it can be done, but a lot of those businesses are VC funded because you need so much ad in the front end to get people in the door. So that's actually one of those ideas where VC funding can be really valuable. So yeah, you might end up having to look into that.
Yeah, I know some universities will have, like bigger universities will have funds that they sponsor.
Yeah. Yeah, what you're describing right now is a bigger startup that's going to be really hard to bootstrap and probably needs multiple people in roles like a marketing role.
Yeah, yeah. The person I'm counting with is a recent Berkeley graduate, so we're definitely looking into their fund.
Yeah, you probably need to hire for that. That's a tough one. But I mean, they can be wildly successful and they can scale when they solve a problem. So it's, yeah, they also be very investable because once you get it going, everyone knows you have the economics of it makes sense, but you do have to prove it out. Which is one of the reasons Airbnb took a while. Once they proved out the thing, they threw money at that, grew it to the moon. But you do have to prove it out first, and it is quite challenging. Okay. You got any more takers? Yeah.
You mentioned earlier about how it's really important to find something that like motivates you. Do you have any like tips on going about finding like what really motivates me?
That's a good question. Just go right to the heart of it, huh? All right, what motivates? Yeah, that's a good question. I think you have to, and this is like life advice now. This is like, what do I want written on my tombstone style advice, right? Because I've read a lot of books about this sort of thing and trying to figure out, what is it that I really want? Because you really do need to find something that is motivational, right? Like you have to have something in your life that is a big enough problem, that's big and juicy to really sink your teeth into, or you'll get bored. So it's, what is big enough that I want that I could spend the rest of my life on? That kind of thought. Just take a lot of introspection. I like the what do I want written on my tombstone thought. Like, if you only have a few words, what would you like to be said about you when you're done? Yeah. Also, just looking at it can be helpful to think about like your biases or like the mistakes that you tend to make or like your general patterns. Just trying to step outside of yourself and be like, these are the mistakes I make. These are the things I feel stupid about. These are my weaknesses, and trying to identify those weaknesses, then identify your strengths, and just try to step outside of it and get outside of your own ego. It's so hard to do. But if you can pull that off and have that kind of introspection, you can make much better decisions. So thanks for the question. That's a good one. I wish I had a really, really good pithy answer for that. Anyone else? Yeah. What was that? So yeah. What's wrong?
I guess following up on the last question, would you say that there was ever a moment for you when you realized that it was worth it? Like the hardships of entrepreneurship, I guess?
A limit or
just like a moment when you thought that like you found catharsis or like you're glad for what you did?
Oh, yeah. Okay. Yeah. Okay. Awesome. Thanks. Okay. The catharsis for me was with calligraphy. Because I taught myself how, my wife had been teaching calligraphy for years. I had just taught myself how to program. And my first app, we launched it together. And I'm like, I don't think anyone's going to buy this thing. I just don't think. And that first day we had a sale. We made like $90 on the sale. Oh, shoot. And the second day we had a sale. And the third day we had 2 sales. And then it was like onesies and twosies for like a month or 2. Then after like 3 months, it was like a 3sies and 4sies. And then it was 4, 5, 6. After like about 6 months in, we're making like 7 sales a day. I'm making like $700 a day off this business. Which there was no cost basis for it. It's one other thing on AWS. So yeah. And it was like, oh shoot, this is gonna work. And yeah, so after a year of that, I quit my job. And yeah, it was crazy. It was awesome. Yeah.
Do you mind me asking, like what led you to go back to the workforce from being an entrepreneur? Because I feel like most entrepreneurs like are employable, after they run one of the company, like just can't really work for other people.
It's really hard.
So what led you to go back? If you don't mind asking?
No, that's good. Financial necessity, failure. I was gonna, I've got 3 kids and a wife and a house. And in October of 2017, if I didn't get a job in October of 2017, I was gonna have to sell a car. I had 2 cars to sell. I was gonna have to sell one, but I was gonna need the other one to get around. I was out of money. And it was like, well, shoot, if I don't do this now. And so I got the job. I took the first offer I got. And yeah, just did that for a bit. Yeah, you're right. Unemployable becomes right? And I had to struggle with that. And the people I worked for struggled with it. We were like fighting all the time because I wanted the autonomy they were not going to give me. Right? I was like ruined. And so I've had to like learn how to work for other people again. And it's really hard. Yeah, right? You realize after a while it's really hard to work for other people. It gets embedded in your personality that you do what you want. Like, no, I do what I want.
Yeah, I'm like a workaholic. I'll work like 3 a.m. in the morning, I'll text someone, get mad, go get back at me.
Yeah.
What the hell, you better sleep.
And that doesn't work in businesses.
Yeah.
Businesses have hours and expectations and deadlines and requirements documents that you have to fulfill. And your boss gets angry with you if you break prod. Like, yeah, my CTO loves me except when I break prod. He was getting after me the other day. It's not a big deal. Except it kind of was, it kind of broke some stuff. But yeah.
Just leave it up to the ops team.
Yeah, like someone else. It was the ops team that did it. I broke the tool where the ops team puts their data in, so every time they saved a record, it was overwriting some of the data. And we lost a lot of data. Yeah, that was my fault.
Did you guys have backups?
Oh no, not for that.
Oh.
So they got to read it all. Yeah, that's stupid. Yeah, I think catharsis was definitely when that started taking off. And then the first time I remember the first time we made $1,000 in a day. I was like, well, shoot. And then we had a Christmas season where we made about 40K in a month. I was like, well, shoot, I'm going to retire on this business. This is going to be the rest of my life. Awesome. I'm going to make it. And then it turns out, didn't know this, but the calligraphy online teaching business is seasonal. It spikes at Christmas and drops off after that. So then I watched this have a seasonal spike. I thought that was real. It wasn't. It dipped. And then it got to ride the wave for a few years. And then, yeah, eventually the wave ran out and I had to go. But that was a lot of fun. It was really exciting. It was, most people never even get that. So that actually was kind of uncommon to even get that, especially right out the gate.
I think for me, we actually don't have like customers yet, like actually building the whole thing, programming for months on end. Like that can be rewarding in and of itself. Because it's like, hey, I built this thing. While all my friends are just doing basic like 100-liner websites, I put in all this infrastructure and I understand what's going on. And if it doesn't work out, I can use this. I actually go to work for someone else as evidence that I know how to do a lot of things.
Yes. When I finally learned how to work for people again, I became very valuable. For that very reason, because I can start something from scratch. I can spin it up, NPM init, and start rolling. And I can take it all the way to prod and get users. I'm not very good at getting users, but I can take it all the way to prod. Not many people can do that. What you'll discover is that's actually a subset of people that even want to do that. Most people don't. Most developers don't want to do that whole end-to-end. Most people end up wanting to do one part of it, and they get really good at it and they love it. And they don't want to do the nastiness of the login, like the login screen. Someone wants to write a login screen. It's not why we got into this career path. So you have to find, I can do it. My personality, for whatever reason, loves perfecting login screens, so I can do that. But yeah, part of that was just like we said, I discovered that I personally like the user experience. I like kind of smooth things out. And so I do the back end of the website so that I can't do the front end of the website. For most back-end developers are like, no, I just want to work on the back end, forget that, you know, like some other poor soul writing all that React. I think we still have some time if you want to keep going involved. If anyone's got any more?
I'll say one thing. I've worked in a bunch of startups and started ups, failed as well, and corporate and everything in between. One thing I learned, not all in, like, you get the mindset that investors are going to put money into your company and they're going to grow your company to grow revenue. And that's really, I don't think is accurate. I think investors want to put money into a company to flip it and sell it. And so if you're starting your own company and you said that you were doing something and you're making money, you're like the old style, the old school. Congratulations. I worked for a guy like that. I was pretty impressed with him, where it's owner financing. You know, they're taking out a loan on their house or whatever, and they're getting grants and they're starting a business, and then they're selling things, and based upon what they're selling as the revenue, they start paying other people to work with them. And they don't need an investor, right?
Yeah.
And when they start talking to these investors, the investors, they're not even interested in them because they're not at millions of dollars. And if he was at millions of dollars of revenue, he wouldn't be looking for investors. But it's, you know, it's only to make that comment because people think, oh, I'm going to get an investor. They're going to help me grow this business. No, you're not.
No, you're not. And you're going to work for that investor.
Yeah. That's the other thing is now it's no longer your company, it's the investor's company.
Yep. You got a boss.
Yeah.
Whether you thought you did and think you do or not, you've got a boss now. So yeah, taking investment is a pretty big step. And this leads me to another sort of point, which is you really want to work for good people. Like this is the most critical thing. When you do end up co-founding, it's like getting married. That is such a big decision. Who you co-found with, or if you join an early startup, who your CEO is, who your leadership team is, because they will determine the course of that whole thing. And I've partnered twice, at least twice. Maybe I'm missing some. At least twice I've partnered with people. Great people, love them. Like really good people. We agreed on the vision and everything. But we just didn't work well enough together, or they couldn't fulfill the part I thought they were going to fulfill, and I couldn't do the part they thought I could do, and we just had some mismatch and it blew up. So I've done that at least twice. That's really, really common, and I think because I have had those experiences, I'm just so careful now. I'm such a jerk. I'm so careful. I'm so picky. I don't want to work for anybody. I'm just a hard sell. You just become a harder and harder sell. And it's harder to get you to do stuff over time. But I can do that though, because like you said, I have that experience now, right? You've got to get that experience. And the experience you gain building something on your own is unparalleled. Like nothing as good as building it all yourself. Because you don't have anyone to ask questions to. You're sitting there at your computer typing, and the dang thing won't work, and it won't build, or this API is not responding like it's supposed to. And typically, at your job, you'd ask somebody who would know the answer, or at least be able to help you. But for a few years, I didn't get to ask anyone for help ever, and I got confident in getting that solved by myself. I'd pull down their source code, read their source code, to figure out how that API really does respond. And eventually, you learn how to read other people's source code, and you get this ability to not ask for help anymore, which is crazy. Super valuable. And companies get really excited. CTOs love it when they can just point you in a direction and say, hey, can you do that? Like, yeah, sure, I'll take care of it. And a month later you come back, it's all buttoned up. That was it? Yeah, what's next? Like they just can't believe it when someone does that. And it isn't like iterating and asking kinds of questions or having all these struggles. Because most of the time in our lives, we're struggling a lot. But you learn how to get that solved on your own when you do that kind of entrepreneurship. So it's really valuable. All right, yeah?
I have one question about this. So a lot of startups, at least like when we talk about like, especially in tech, but I guess in general, there's like one format, like usually it's like one person or like a couple people starting it and like either being investors or like remaining the sole owners. But as far as like, because I've read different things about like survivability of like various forms of startups, and like co-ops seem to have a higher like survivability rate. But I was wondering if you had like the experience or knowledge of like how that like can translate into tech, because there's not many like tech co-ops that I've seen, but there's like other companies that aren't in tech that like transitioned into that.
I mean, co-ops like
No, like
like a group of people getting together to solve a problem.
sort of like a joint venture, but where much of the, instead of like the, for example, like executives owning most of the ownership, it's like a lot of the employees themselves also have like a stable company. Like an example is like what's the brewing company in Asheville? New Belgium. They were a co-op until like I think it was Coors or some other company recently acquired them, and they.
That's awesome.
Yeah, but so there's a study that I read about how among different types of ownership within startups, how they can have the highest survivability rate, so they tend to retain their employees. So I was wondering if you had any like stories about that or like knowledge about exactly like how to even like how that you can even approach that, because you always hear these stories about like you get capital as a person, you bootstrap it yourself with friends, but like how would you do something more large scale like that?
So that you're really getting into equity distribution, which is a really interesting topic. A lot of different opinions about that. So like the way MailChimp did it, the guy who started it, he bootstrapped that sucker and he didn't give away the equity. He just paid everybody a lot. And so he didn't give away equity. When he sold it, he had like 90% equity or something stupid like that. He took the billions for himself. So that's one way. That's one way that it can be done. The more egalitarian direction is really hard to do with VCs, because VCs want to take a bunch of you. They want a lot of your company. If they can't get a big chunk, they're not going to invest at all. So you have to have a lot of your cap table, your shares, have to be allocated to investors. That's why it's so hard to do a co-op with like a VC funded thing, because you're not going to be left with anything. It's like starting a band with 7 members. You know, you have to be really successful, and no one's going to be able to live off the thing. If it's just a solo album, it's a little bit easier. So typically, what happens is there are different approaches to how much to give to people, to give to your employees, but giving them significant equity is very motivational. But that significant equity may be 0.25%. Because if you've got millions of dollars, they just got invested in the business, you give someone 0.25%, you're giving them 0.25% of that valuation. So the numbers get really tough to justify, giving an employee tons of equity. You tend to, if you like percentages over like 1 or 2, a lot of times that's like only executives look at that. So yeah, I don't see a lot of co-op stuff. There's got to be a reason for it. Yeah, I'm really curious now whether anyone has successfully done that.
So I was thinking of there's a company, I think it was Zappos, the shoe company.
Yeah.
They partially did a transition to like they did a giant like redistribution of their equity among their employees. I forget what it was called because it wasn't like a full co-op, but I was just interested because I've seen various co-ops and come across a lot of them like over like my time interacting with other businesses, but I've never seen any in tech. I was wondering if that's because in tech we're so heavily dependent upon VCs and investors rather than sort of more of a gradual natural growth. Because I think we have a lot of this like a lot of companies, especially like now there's talk of how a lot of companies in tech gain their value through sort of speculation and their value getting overvalued. By pumping out numbers that seem good to investors and then don't pay off.
You know, I bet if co-ops have succeeded, they probably just haven't gotten headlines, and probably just not been VC funded, right? It's probably under the radar. Because there are a lot of businesses that are like bootstrap that sell business to business that don't even sell to consumers. You would never hear their name. They can be making tons of money, and they may just be 1 or 2 people running the thing. Like that's like a lot of the most successful bootstrap businesses never. The easiest way, and this is kind of what you're running into with the two-sided marketplace, selling to business is so much easier than selling to consumers. Consumers are miserable to sell to, but selling to business is way more straightforward. The deal though is selling to businesses, no one knows your name. Like you and I, we don't know the names of all these business-to-business companies at all. So yeah, it would have to be something like that maybe. I don't know. Hyperscale businesses that go, hyperscale is usually business to consumer, and that sort of hyperscale stuff always needs to be seen. All right. Yeah.
This isn't really a question about starting a company, but like I work at a unicorn right now, and I'm wondering, like, when they issue you stock grants in addition to like a base salary, like, is that basically paper money until they let you go?
Usually. But I say that, but the last 2 companies I've worked at, both got purchased, and I got equity payouts from both of them.
Because they got bought out.
Yeah. Or IPO. First company, the one I started in 2017, I worked there a year and a half. They sold. I got paid out. I quit, went to another company, stayed there 2 years. They sold, got paid out, and quit, couldn't sell. So I'm looking for my 3rd in a row. But the key thing to recognize is even if it does pay out, it's probably not a lot. So think tens of thousands of dollars, not hundreds, usually.
But you know, what happens if you never pay out or you never IPO and you're there for 8 years, but you don't want to stay for 10 years?
Oh yeah, that's most companies, yeah. That's exactly what usually happens. Almost always. So I've gotten lucky with 2, but it's very uncommon that works out. Yeah.
Yes, I had a similar experience. I had options grant in something. I was the first engineer there. They got bought out by Barracuda, but they gave a deal of like kind of like a golden anchor. So that was built into the new bill. So those of us who had that options grant, that was part of our new base pay, but that also meant actually working for it.
Yeah. It's like an acqui-hire kind of thing?
It was like completely, yeah. They completely took the whole team and everyone. They actually wanted the team.
They wanted the team.
Because they had a competing product, Barracuda had a competing product. They wanted to absorb the whole product. And like, they didn't even worry just about the customers. Like, they were like, oh yeah, fine, we will take them. But we want you to so that kind of. So they built it in such a way that it becomes like a golden anchor.
Yep. And the golden handcuffs, just to be real quick, can be the most profitable thing we do.
Yeah.
Like, there's a reason so many people want to go work for Google and Facebook, right? You want those golden handcuffs. Like, sometimes it can get a little soulless, like you may get tired of your job, but then you can't quit, but you keep doing the job because you're paying too much. I've got friends who have been working at companies for a long time. I don't know if they still love it. They won't talk about it. Like, after 10 years doing the same job, maybe you don't love it anymore. I don't know. But they're guaranteed to make good money. So it can be hard to quit. Yeah. Cool. All right, well, let's call it. We're done. Thanks, guys.
Thank you so much, Chris, for this talk. I think everyone enjoyed it a lot. We'll now be just moving on to the fun part of today, which is the trivia game. Andrew and his team from GDXC at UNC have a trivia for everyone.
Anand, you skipped over the networking thing.
The plan is to do that after the trivia.
Very good.
And for those of you here, this trivia is actually UNC like comp sci theme. So I know some of you guys aren't exactly students here, but try your best. And the winner of the trivia
We'll give them extra roles for the trivia, not the trivia, the raffle.
For the raffle prizes, which they are 2 Google Home Minis and
One Google Nest Hub.
1 Google Nest Hub as the grand prize. So we'll get that set up right now.
Is the display thing?
First.
We actually had networking from 2 to 2:30, but we did Chris's talk.
This might actually tailor.
Also, once you open it, just remember to share screen.
So that is all available online.
Does this have audio?
It
The
does.
Kahoot audio?
Yes.
That'd be fun. Is this playing any audio? Try something. Yeah. We got a screen share.
Screen share here. I guess it's fine if it's
Full screen. Select.
So off and on.
Are you gonna show that?
F11. You'll leave it?
Yeah.
I'll be here just in case. Can you open this? Like I'm trying to
Yes.
create that form.
No. When was the last time you guys played Kahoot? I feel like it's like a high school thing.
I'm too old. It's kind of like high school. 2010?
Yeah. To my fellow peers who are still studying. Let's see.
Wait, you were born after like 2000, right?
Correct.
You were?
Yes.
Yeah.
2002. We have some boomers in the crowd.
I turned 40 last month.
Yeah. So this might be a whole new experience for you.
I have done a couple of Kahoots, but that was always at like work events.
Mm-hmm. Is anyone still trying to get into the game? Otherwise, I think it's done.
Sorry, get a password and then,
I was thinking, do you just want to give one of the Google Minis to the winner of the Kahoot, or do you just want to actually?
Let's do that? Yeah, that would be better.
That would be more.
Just announce that.
So we actually decided that the winner of this Kahoot is going to be the one taking home
Just
a
making
Google
the
Mini.
feedback
So that's out a little competition a little bit. Thank you, Chris.
Thank you.
All right, so is that everyone?
no, so I had to like reset it and just like save it, create it, and yada yada. It was work.
We can just keep them here.
It's
Or we can just put them
mostly
back.
like UNC, CS. I actually haven't really looked at the questions that much. It was my core team that made it. But yeah, it's essentially UNC trivia with some CS singled in there.
If anyone wants an extra shirt, there's the t-shirts. I think we had questions about that earlier. So I was like, yeah, very easy.
Oh, by the way, I checked it. Should we still do it? Check-in? Check-in was on my laptop.
Yeah.
Yes, yes.
My email should be MAT.
Just me that.
Ours can seem like a week ago.
It must be here, but like. You can just search.
Two. Yeah. All right, thank you.
We need to check in. Yeah, that auto checking. Yeah, that automatically checks.
So that's the.
We have worked with Andrew's gonna run this. I think I got one. Not sure. No, I did not. I think I need to get one.
Use part of your budget for that?
Huh?
Use part of your budget for that?
Yeah.
So you get reimbursed after, right? Just go to the
Yeah.
store.
Okay, I believe that's everyone. Then we'll just get started. And also, if you don't know how Kahoot works, obviously you get points for the right answer, but the quicker that you answer, the more points you get. So that's also something to consider.
The answer is embarrassing. I'm not just like on Marvel.
Oh, is it? And I apologize if these questions are too difficult. I had no part in making this. Trick question, that's the building we're in right now.
This is all about Carolina.
Is it one of the quads?
Yes.
Okay.
Guys, it's Tim Apple. Bring Tim.
Oh my God, I think the fancy something. Oh, it's just like too fast.
What?
Feel bad. It was a Charlotte.
Probably gonna. How about you? I really react.
There we go.
Oh. I read something we can do that once. Nice.
I think that answer was obvious. I don't know who selected this.
It's like
The top two people get the. I know this one.
Put your guessing skills to the test. We're more than halfway through.
No, it's definitely better. Not just old.
It was earlier this semester.
Thanks.
The new leader is on board. I have no idea. I've never seen that on campus. Yeah. All right. We're coming down to the wire.
That guy also wrote the Mythical Man book. Mythical Month. Mythical Man Month book. Actually got the date right there. After I guess the answer.
All right. Here's the final round. All right.
This was stolen.
So the moment of truth.
This is just like the national championship last year.
In third place. Jewish. Seth for number 2. And number 1, Stefano. So you will be taking also, you want your photo taken for the DSC Instagram page.
He gets to be on the Instagram. Oh my God.
Those are right. One of them's
Take the other one out. Just put that out there.
Okay, and then are we going straight into John's
Networking.
stuff, or we just go?
We're gonna do networking and then.
Okay, then.
That dude Seth with that score of 4 digits.
I agree. It's kind of cool how he was able to get it like the perfect package on Friday.
Yeah.
Perfect.
I'm trying to get some back.
Yeah, so for USB, I have a battery bank. Can use my battery bank. It's in that bag.
So we're gonna do the networking.
I was just
Now.
I've never heard of it.
Yeah, no, I'm
Would you want to say like next?
Basically, yeah, the plan is I also created like a table thing online. So I'm just adding a table for networking.
Okay.
Increase that to like 5. So we can, I think, just show them through this. So guys, now we just have some time for networking. So you can just, just get up and perhaps grab something to drink and just have a chill time with just networking with others, share your LinkedIns, and we can do this. If you want to share about yourself from this stage, just come up here, grab a mic, and just talk about yourself and put your LinkedIn in the chat so that everyone who's joining us remotely, they can also connect with you. So we have that option open if anyone wants to do that. Yeah. So, and we also have, if you're joining us live online, if you can see this mouse on my screen, there's this networking tab, but I don't want to leave this session because that's where I'm streaming from. But if you hit networking, it should take you to the networking page from where you can join the networking table, and it will let you do a video call and other people can join and you all can chat online and share anything and get connected. So yeah, we will start John's talk, which is the last but not least talk of the day. That's going to be TensorFlow from the ground up. So that's coming up soon. Let's shoot for 3:45 for that talk. So we have about 30 minutes to do networking. So yeah, let's get started.
And
You want to share your link?
Yes. I did in high school. I ended it freshman year. It was like an e-commerce spice business. Yeah, so we make in-house bread and then we also sold Oh, yeah. We started making those towards the end, but it was just more that's.
come with me.
Plus there was students where like
That works too. Yeah.
But yeah.
This one was
If not,
This was much. This was
I'm gonna go. I'm gonna go.
Yeah, I got lucky.
You
Because I was on, so I was shot up. So I got some business. Well, obviously that was related. Restaurants. Like I said, I still think I would be. Oh, yeah.
People are just connecting things. Yeah, and just walk around and talk to people.
No, actually,
I think I'm.
members of this.
I'm sorry. Typically, yeah, this is basically the hour. I believe it's like I was like, it's been sure. Are you a UNC? Yes. Oh, wow. Okay. We have some good schools. So you graduated? I'm graduating. I'm second year, so I'm graduating next year. You're supposed to see I feel like, especially just take a guess.
Because it tends to be like besides the major, there's also the market for clubs within the comp center is very saturated. There's like 6 clubs overlapping.
So were you streaming just what the students are pretty high on?
Yeah.
So you're not like, there's no other cameras.
So there's a camera facing this way. There's also screen. Yeah, so there's a screen share that we are doing, and there's a camera that's facing this way that we are also showing.
Yeah, like a lot of them overlap. Yeah, exactly. The part that's weird about like, because a lot of people use the margin like from the department, and it could be integrated with like one food. Yeah, I think it's they don't really care about that. Plus, we have a whole lot of funding.
So it's like, best practices back end. So like, for example, we have, right now we have microservices, I think we have like 50 microservices. And they talk to each other once in a while. So our team just has some internally sort of ours right now, so it's just improving that specific part. I really do want to hang out with my product. So that's something I'm really looking for.
So these are even work on it, Oh, wow, okay. Yeah,
It's actually based in songs because it's the company. Yeah. That's really fun. Yeah, they have the office. Yeah. So what's your
I don't know why I thought it was just. You know, there's now I'm going to do this first. Yeah, when I actually about a year ago,
what?
I remember because I went on
I'll come with you and see shows. So it's like, okay. But like, everything about this. And then I slowly realized that it was just all the prejudices I had about other things that they did. Sign off, so people don't put up fences around your house. What? We drive a car. It's not very important. But like also they just do other things. Their houses are getting material, they have trees, lots of things. So it's convenient. I almost crashed my car here because I was working for college. I was working in restaurants. I was working till like midnight, and I needed to drive home. So I started driving, and and then just really actually. Yeah, that sounds kind of like motor. It's gotta be like half. Consider myself. Well, that was high school. But no, I didn't adventure as high school. I didn't take over 40 classes.
Yeah, it was really it's so easy. You have to
so there are people who just get on.
Yeah, that's a lot.
No, I wasn't that I wouldn't even go as far as to say really low. I would say slightly low. Great job. By the way. Oh, yeah.
Yeah, but at the end of the oh, it's great. You didn't really think a lot of it. You know, so we didn't do that. It was alright. So basically, yeah, I was wondering if so we used OpenStreetMap data. OpenStreetMap is for sort of walking bases, like collections of vertices. It's also provides buildings. So we use OpenStreetMap data to buildings to walk this walking distance. Those pictures on my phone, where you need to walk.
So that's it.
Yeah, OpenStreetMap actually, there's multiple websites that mirror like central data, but they all use common API. It's like
It's nice. It has its pros and cons. Thank you. I used to like JS, so we use it. But I was starting to. I'm not liking it as much as I was in Seattle. And like I miss that thing. Yeah. There's so much more available. Yeah.
Well, the jet is that's their plan.
I wonder why that is.
Oh, yeah. Why the obstacles in the system and it'll still go around. It wouldn't show what it's more than. Well, for sure. One of the factors that like the metrics that was I didn't check that. I was never.
That's
I honestly, I realized so many. No, I think we just kind of like, yeah, so like, what do you guys do? Basically, but if you look at the companies, oh yeah. I think weird things like I got I don't usually I used to be into those, right? So like that's the market. Like 10 years, you will be right? So our generation is helpful. That's what stands for. You really realize that's what it but it's interesting when you use it here. And I'm glad
So that's I don't know. What I realized. Yeah, well,
No, there was a whole bunch back in that room. I would go back there and look. I'm not the organizer. I'm from Durham. These guys.
Yeah. We have a lot of stuff. Yeah, I'll bring up a lot of no, it's like it's because a lot of people when they see like honest startup, just like an aspiration, has that air of like success. So like yeah, oh yeah.
So that's JavaScript was kind of but I want to do that. I had that job. I would
I've never been. I was watching. Probably this was my step in.
Yeah, I just more responsibility.
My roommate I have one power.
Me, actually, is one person. And I never get that. That's just. Oh. Okay. I turned myself down.
That's all I like.
We do that.
I'm not sure how I do it.
Yeah. I know. I connected someone in like 4 years. I'm still waiting for him to find this. I'm at like everyone's talking like.
But yeah, you gotta look at it.
It's a lot. Yeah. I don't connect with that's like my whole. Someone's like, yes, I'll probably do it. It's some random person. It's how dark. It's like, you know, I only did it.
She gotta head out.
Yes. Yeah. Yeah.
You too.
going to hire a part-time remote entry-level software engineer. Oh, it's really nice. I kind of just see that. I didn't have school.
Of course, we cannot always keep doing.
Sure. You build tools, that's true.
Well, I feel, yeah, that's, it's like, I think that's stressful. Yeah, but there's.
Yeah, but I don't know. Oh, do you guys usually have the water? We did this on.
That's why I told you.
Look, you guys, for example, 2 days, second 2 days. So the next two right now, is using yeah. There are a lot of them, they want to make, we want yeah. So I wrote Python script.
It's a good Holland. What do you think about that? This is a good place to get the MBA. How do you get into the MBA?
Sorry,
Lunch. Cool. We gotta start, I think.
Do you want me to call it, John?
Yeah, let's go. All right, everyone. So hope you made some new connections and enjoyed this networking time. We are back with John, who's gonna lead the next talk, the next session, and that's gonna be about TensorFlow from the ground up. This is gonna be our last talk for the day. So yeah, let's get started.
All right, thank you. Thank you, Anna. I appreciate it.
Give me a slide or something.
All right, so what I'm gonna try to do is I'm gonna try to open another tab, and we're just gonna go from there. All right, so I'm not gonna tell you about me or being prestigious. I'm gonna tell you about the users group that I started in 2018, which is RTP GCP Research Triangle Park. We are officially in the GDG nomenclature, GDG Cloud RTP. We meet every week, and we have an hour where we have a workshop. We don't really bring people in to speak. If they want, they can, but in reality, we do things. So this talk, you can look at it there, is here. This is the slide deck. So we're going to talk this slide deck, and what I wouldn't mind, I'm just going to leave it like this because I'm going to kind of go back and forth. Present, view, present. Before I do that, let me do one last thing. So this talk is offered by Google as part of their GDG program.
Hi everyone, my name is Walt.
For their fall campaign. It's one of the 4 ML topics. I didn't know this until I started looking at it. This is from the original source. This guy, Wolf, he did this as part of the TensorFlow group, and it looks like these are his slides. If you look at the slide deck and you were to follow him along, you would literally see things like word for word. With that said, I want to point out to a comment here. This guy says, I've been using TensorFlow for 3 years now, and I'm a certified TensorFlow developer, and I feel like I learned so much from the lower level stuff. Yada, yada. Definitely not a talk for beginners, whatever. So with that said, I want to say, I don't know why there's a thing that's up here. You can't see very good. Press to minimize image. I didn't write this. I don't want to pretend I wrote it. I just went through it, and then I added a notebook that goes along with it. And I would encourage you, if you're following along at home, to open this Jupyter notebook up, which is really Colab, and just kind of follow along with us. Because the guy says it's not a beginner's lesson, but I think with the notebook that I've got here, you can kind of follow along. You can kind of see what he's doing where he just glosses over things. So we're going to flip back and forth between these two. So for the URLs, there is the URL for what we do in RTP GCP, and you look me up on LinkedIn, which is the previous slide. I advertise each week. We're Sundays at 10 a.m. The gradients introduction, I think, is just one of the URLs. So the other thing is that guy did 90 slides in 30 minutes. I'm hoping that we do 50 slides in an hour. So, all right. So what are we doing? In lower level talk about TensorFlow, we'll cover fundamental topics. We're not really going to, so it's probably machine learning, and I'm not going to say we're going to do machine learning, Python. Like I said, if you were to watch the video, this is what the guy would be saying with these slides. Everybody knows that you have data, you have weights on a model, the training updates your weights, yada, yada, yada. TensorFlow has a lot going on. I was talking with somebody earlier, they were saying that they had done Keras. When I first started doing TensorFlow, Keras was its own thing, and you could either use PyTorch or TensorFlow as your implementation. Now TensorFlow is like moved up. It's part of it. It's not like something that you use separately that implements in TensorFlow. Sonnet, I think I mentioned to somebody, is a newer thing, which is, I know very little. I've just seen them on the GitHub. I don't know anything about these things, but I do remember when TFX came out, and I think that's kind of like for feature transformations. I would like to learn about it. I don't know. So anyway, there's a kind of a joke, you put anything numpy at the end of it and you get numpy results. All right, so where are we going? So this says TensorFlow from the middle up, meaning that he's going to talk about the graph, eager mode versus compilation mode. Like I said, when I did it, eager mode wasn't there. You had to like enable it later. I don't, but it doesn't matter. We're just going to look at the graph and how to like what it is, right? The basics. So this thing here is going to, it talks about tensors, variables, modules, gradients, and function, what those things are. I'm thinking that we're probably going to get through all of this. If we don't, no problem. So TensorFlow is a graph-oriented programming language. You have things that are tensors and you have things that are ops. Anybody following on that? What a tensor is? Anybody know? A tensor is just a matrix. It's just another word for it, right? You can have a various degrees. You can have a scalar. You can have a 1D, a 2D, 3D, ND, right? And ops are things that you're going to transform through the graph, right? What's a tensor? He's going to talk to tensor specifically. So here's one that's a scalar. Here's one that's a 1D. Here's a 2D. Here's one that's not just numbers, right? And for something like this, I think you're really going to encode it, right? So static tensor, yada, yada, yada. Tensors are strongly typed, like you want to have them all of the same type, I believe. Here's an example of an image. This is from the Fashionist data set. One thing I thought about the Fashionist data set is like clothing articles, and you can build classifiers on the clothing articles to say, given this picture, what is it? It'll have like, sandals, socks, shoes, and things like that. This actually might be from the NIST data set. I'm sorry, I said Fashionist. I think this is just from the NIST data set. This is where they were trying to do number identification. And what they're showing is, here is on the left is a bitmap. Here on the right is an array matrix tensor that is representing that grayscale image. And everybody see that, right? That's easy to understand. This is the higher the number is, the more black that's in it. That's all that is, right? And then nodding heads. Okay. All right, so here is just, he's got some code up here. He's just showing you how to define those things. The first one is, it's a rank 0 or a scalar, right? It's just one number. Here's an array. So you have a real and imaginary. It's two tensors, which are both numbers, right? And what he's going to do is he's going to put them together to make a complex. And so the real part, if you notice the 2.25 and the 3.25, they're going to come into play so that they're there, the real part, when he prints it out. He's just putting a comment. And then here is like he's doing a type string, which, like I said, I think later on it will get like converted to a number. With that said, click here. This just has like the code necessary. This also, you can make a copy of this. We'll just click connect. Anytime you see a heading over here in the markdown, I try to put like the comments about how to, how to do things with it. You can click here, it'll take you to the section. If you see things like so, you just need to expand them. I will just make sure that we're connected. We at least import TensorFlow so that later everything can be done. Share up here so you can see this. So I think that ran, is it a green check mark? Yeah, okay, so good, so it's running. Then that just runs the cell. You hit Shift Enter. This is the same code that was doing the that he had up there. Yada yada yada. It's not that big a deal. I don't know if some people don't. I don't know when I was talking to the guy earlier, didn't use these notebooks. You can print out results a couple of different ways. You can say like, I just want to see the last thing that was an operation. You'll get a value. So right here you can see a rank 2 tensor, which is this guy. It's printed out down here, right? You can, rather than do that, you can comment that out. Come down, we'll see that there's a print there. Actually, because that was, let me do this, because that was there, this was not actually being run. But then you could do this, take this back out. It doesn't matter, it's not going to be shown because you actually have an executable after, it's just going to be the one, all right? So you can play with that. As far as dimensions, past 3D, it's kind of hard, or really 4D. So with 3D, you've got X, Y, and Z. And so you could have things like, I want to have a fourth dimension, kind of think of that as a list of 3D images, right? Or 3D arrays. So now when you go to like a 5, it's like really hard for me to visualize, but it doesn't really matter because you don't have to visualize everything. And a lot of times you'll see in images, just as an aside, you'll see NCW, which is N is like your batch, C is your color channels. So the N would be like how many images are there, C would be the red, green, blue, or it would just be one number for a grayscale, and then the height and width. So that would be height, width, C for your channel, and your batch. That would be a 4D tensor. Let's look at it that way. This is showing you how to do different things here, like with the ranks, just experimenting with it. Same as there, same as there. It's like all of this is kind of simple, no big deal. He's just showing you how to make the different ranks. One of the ways in order to get the numbers is using brackets, right? 1, 2, 3. So that's a rank 3 because you would need 3 indexes to get to this point, right? Let's see what else. Here. So other ways to look at a rank 3 tensor is like so. You could remember when I was talking about red, green, blue? So if you were to look at this and say this is a 2 by 8 pixel array, 2 by 5 pixel array, this could be the values for your red, this could be the values for your green, this is the values for blue, or really green, blue, and red. Shape. Shape is, I don't know if you remember the first guy that was up here. Remember he was typing in shape and he had that little tuple, had the 2 numbers. That's just your width and height, right? If you've got 3 elements, it would be 3 elements there, right? Or 3 dimensions, you'd have 3 elements. Rank, same thing. Axis, they typically go axis 0 is the first number in your shape, the next number. And we'll do some of this in the book. So here, once again, talking about a tensor. And I knew he was going to talk about images, but this is exactly it. This, well, he says height, width, and batch, and then he puts features at the end. So features here might be like the color, but like I said, I would think it would be the opposite. I would think that this would be a CHWN where there's 5 images, red, green, blue, and then the 2 height and width. So I'm not really sure why he did it that way, but whatever. I think I showed you that code in the notebook already. And then these are your ops. These are the things that transform, right? So matrix multiply, minimum, argmax, yada, yada, yada. The @ symbol is a,
We're not streaming.
we're not streaming. Let me get out of the way. I can do a dance now. This is a dance of my people. I'm holding on to this and typing at the same time. Kind of reminds me I'm doing some floor work and I've got the heat gun in one hand and then I've got this putty knife trying to scrape. Becoming ambidextrous here. While we're looking, anybody use TensorFlow? Anybody have a burning interest in TensorFlow? I remember you did. Yeah, yeah.
A little bit.
A little bit, good, good. Anybody else? Interest?
I have a question.
Yeah, yep.
Have you used TensorFlow Lite or converted TensorFlow to TensorFlow Lite?
I haven't done any with TensorFlow Lite, but my understanding is you use that with like the JavaScript stuff, right?
Yeah, it seems like I was learning about it at the talk.
Yeah.
It seemed like it was just more for like.
Is it prediction maybe? Only for prediction? You don't do training maybe?
It was intended. There are use cases that things from the TensorFlow advocate. His use cases for TensorFlow Lite were around like standalone devices.
Yeah.
That don't require internet connections.
So maybe that would be its prediction only, right? Right. So you have a model and you deploy it and it's doing prediction. But then again, I remember seeing like a demo one time where they had the model, they had trained it, and they had done something for like reinforcement learning where you could click on like you would see a color or something. You would say, this is the red color. See another could be like blue or something. And you could kind of train it to learn something. I can't remember what it was, but it was a device and it wasn't like a full blown TPU and it wasn't like a big computer. So I don't really know. It's one of the things I would like to learn about is more on the JavaScript side and the TF Lite. There's a lot of stuff. And that's why we do. So in my group, we do stuff every week, but we kind of like, hit different topics. And some of that was just prepping for this. So we spent 2 or 3 weeks going through this. You'd spend an hour, right? And then we've had other times where we talk about just general purpose GCP stuff. So if you ever want to join us, if you have an interest, that's what to do. I do another one with AWS, and we just did 8 weeks covering Kubernetes. So, all right. So the @ symbol is like a matrix multiply. I think that's like a multiply that's element by element versus take your matrix, convert it, slide it, and multiply it like that. Yeah, so element wise, okay, pardon me. Star is element wise ats that way. I have to look this up, and there's actually a matmul thing, just like there's a TF-at. You can use it. All right, so with that, let me just show you a couple of things on that. We'll come back. So here are ops. Oops, I thought I had too many O's in there. Let's see here. We've got 2 constants that are 2 by 2. You're going to print them out. I'm using this style of Python. We've got a result because we have to have a variable to put the result in if we're going to look at it later, right? And it has to be, my understanding is it has to be the same shape as your result, otherwise you'll get an error. And we're going to do a element-wise mul. I'm going to do a little thing down below where you have rows that are going to be repeated. So just keep that in mind. Like if you're doing element-wise, they don't have to be the exact same shape. You could do a 2 by 2 by a 2 by 1, and that 2 by 1 would just be repeated. So Here is another one. This is a true matrix multiply. Now you've got to have the things, they've got to be, the dimensions have to meet, right? So a 2 by 1 times a 1 by 2, the one by 1 in the middle matches, get your outers for what your new dimensions are. Here's a 3 by 2, right? So you can't do this, which is a matrix multiply, because the dimensions don't match. But you can do the matrix multiply. What have I got there? Make sure that's 3 by 2, 3 by 2, and 2 by 2. And Earl's able to do this, right? Okay. But what happens? And then the element wise. So we'll just run this, see if it works. Still should work. So just looking at it, so you can see the A and the B. Let's see what that's right. Yeah, A is 1, 2, 3, 4. Other one's 4, 3, 2, 1. Element wise, multiplying. 4 times 1 is 4. 2 times 6 is 12. Is that there? Or pardon me. 2 times 3 is 6. 2 times 3 is 6 again. 4 times 1 is 4, right? And then here's the other one. This, in this slide over here, he's showing this. He's not telling me what was in this rank 1 tensor, but I think he was using that image. I didn't load an image, so I'm just going to say it's a big image of a bunch of zeros. I think that's an 8 by 8. And then I'm just going to slice the answer so you can see 1, 2, 3, 4, 5, 6, 7, 8, 0 through 7. It's 8. So there's some variable stuff next. Other ops, so you can do like 2D convolution, ReLU, softmask. These are like activation functions. And if one of the things I always say to people, because I thought it was interesting, if you have a neural net and everything is linear, and matrices and linear math, linear algebra, whatever, if it's all linear, you can collapse it, right? So you could have 20 layers. If the connection from layer 1 to layer 2 was linear, then it would all collapse down to one layer, right? Transient property. But by having a nonlinear in there, you can't do that. And then those layers become significant. So what they would do is they would map them. They have that mapping function. ReLU is just a very simple nonlinear function. If it's less than 0, it's 0. If it's greater than 0, it's whatever x is. It's linear. I always like showing people this. Anybody know about TensorFlow Playground? I've got one guy. Anybody? You ought to play with this. This is kind of neat. Playground. Probably getting off topic, but I think it's worth someone seeing. So basically, this thing on the right, the dots are like the training data. The neural network mapping is the background area. So as it is right now with no step, just 4 neurons, he's saying that the left-hand side in this diagonal would be orange and the right-hand side would be blue, given all of the inputs like so. You have, these are your features. You only got 2 features, right? You've got the X and you got the Y, right? So over here, you can see what those are. So he's going to do like, just split it in the middle. If it's anything to the right, we're going to make it blue. If it's this is 0, right? So if X1, which is corresponding to X, is greater than 0, it's blue. If it's less than 0, of course, in the X direction, it's orange. This is your Y. And that's how you get that kind of that pattern, right? 4 neurons, you step it. You've got your activation function. Remember we were talking about that it was ReLU? That's ReLU. I wish there was a thing that I could show you ReLU. You can play with different things. You can add these. I always just, you can add more neurons this way. You can add more layers this way. And like I was saying, if you were to put linear here, it wouldn't matter. It would all get collapsed down to like so. All right, you can play with this. You can step it, yada, yada, yada. That's the big picture of what we're doing. All right, so we're not there yet. So we're just looking at variables. What did I do here? Here was just showing whatever his code was, putting in some bools and some strings, complex. This was updating. So this was saying A is going to be a variable and you're given an initial value. And then later it's the same type and you can assign it, right? Actually, let me rephrase that. This is a different type, but I think it promotes it. So let's see, when you print out A, even though I put integers in there because the other one has a point in it, it stays as a float, but you can't manipulate the size of it. This is a variable that's a 1x2, and you try to put a 1x3 in it, you'll get an exception. So we have tensors, yada, 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 variables. I think this is all that we're showing here. It's showing you can't resize it. And then he makes this big leap to putting variables on devices. So if you have a GPU, you want to put some stuff on the CPU, then on some other stuff on the GPU, this is how you would do it. Let me see if we can do this. Since this is a notebook, right? You can look over here and you can see where the variables, what the values are, what the shape. I don't see any way to say like you're on a GPU or not. Over here, you can go to view resources. I can see like, maybe if you'd had Colab Pro, you could see more of this, like I don't. But if you change the runtime type and you do it as, I'm not going to do it, but if you were to do it and say it's a GPU, I don't think you see an additional column. I do know that you will see another thing over here to say system RAM, disk space, GPU RAM. That's all that is. But, you know, there he is. He's going to say that these variables are going to be on the CPU because he's using the with statement. These are going to be on the GPU. Not that interesting. This is kind of the common thing. You have like your sequence processor, you have your parallel processors, those are your GPUs, right? This thing tells those things what to do. It's the same thing like if you have like MMX instructions, right? I got an instruction that's run on my CPU that tells I want to do an add for these 4 parallel processors, right? MMX back in the day. Right here, he's just showing you some stuff about how you can delete things. So W is a variable, and then we'll explicitly delete it. You can see that in the Colab. So let's get some of this. Go to this ops and lifespan. So I don't know if I can click. Let's just do. What is W? We'll just do it like this. Let's hit Shift Enter. So those are the guys that came up. They're eager tensors because we're in eager mode. The B is a variable, so he's a resource variable, right? And now watch W, which is right here. When we do like so, whoopsie daisy, he should be removed. If I did that right. Oh, maybe not. Let's try this again. W is defined. There we go. Delete him. This should update. Yeah, W goes away. All right, so before we get into the next thing, I just want to show something here because he also gets a little off here. We'll come back. So he has tensors, variables, yada, yada, yada. What about training? Talks about gradient tape. Gradient tape's a way to do derivatives. You all know about gradient descent? Yes, no, maybe. So the whole point is, you got a curve, right? You take the gradient, you find what's velocity and acceleration. Acceleration is the derivative of velocity, right? So you're going to find where you're at. If you get the one that's like going to a minimal, you'll single step down if you keep adjusting to the lowest point, right? Steepest descent. So I know I was doing the reduced mean because it's coming. It was a little out of order. So here's before I do that, he's going to jump right in and try to show you gradient tape with an array. Well, I'm going to show you gradient tape without an array, and we're going to single step it up. So let's hold off here and we'll come back. I think that'll be better. There is a bit about reduce mean. So it's an API in TF. So basically, if I have an array, like here's a 1, 1, 1, 2, 2, if you reduce mean on axis 0, which is this first axis, your row axis, then you're going to get a result of 1.5 and 1.5, right? Because that's the average of 1 and 2. 1 plus 2 is 3. You got two numbers, 3 is 1.5, right? Right? You go the other way, what's the average of 1 and 1? It's 1. Average of 2 and 2 is 2. If you're going to do like the entire reduce mean, meaning you're going to go by both axes and just get one number. And it looks like my thing cut off, or maybe it didn't. There it is. There's 1.5. It doesn't matter which way you go. You can go rows and get that, and then go across that row, you'll get 1.5. Same as there. So just keep that in mind as we go forward. Let's close this resource tab. There we go. All right, so the first thing, and then that's all I'm showing here, right? This is how you do a reduce mean. You've got a variable, you've got your first. It's the same thing as the picture. It's just that you can put it in code. So like if I were to pull this out, anybody got a guess as to what X1 is? See if you're awake. First, so if it was a 0, if I did a 0, what would I be reducing mean against? I'd be going against the rows, right? If I do a 1, it's the axis 2, which is the columns. So what would be the answer if you reduce mean 1? The columns. So like here, you're going to go reduce mean against columns this way. I think it's going to be 1, 2. Maybe I'm wrong. It is. It's 1, 2, right? So this is just showing you how to do that up above there. In the great scheme of things, this means nothing. So about calculus. I think I implemented this, like if you were just going to do a simple variable, like he was doing an array, I'm just going to do 1, and the variable, and I tried to do some of this in Markdown later on. I do y equals x squared, and then you were going to take the gradient of that. X squared would be 2x, right? That's the first derivative. Then you put in the value at 2 times 3 would be 6, right? If you're going to put something in a little bit more complex like this, but you're still not going to an array of numbers, y equals x times w plus b. And that's like your typical thing, right? You have a weights matrix, you have a bias variable, you have your features or x, your output is y. right? So let's say that you're going to say that this is your function, your loss is going to be y squared. You're going to do the same thing on the derivative of the loss. So d loss dw, that's going to be 2y, right? Which is 2y plus b, 2x plus b. Same here. If you were going to do them both simultaneously, you're just going to take those two values. So you would get 2x plus b, and you would get 2y here. Just to kind of verify things as another way, you can take those things and square them and go like so, and that's the FOIL method. And so you can do this because it is squared, right? You're going to square that thing. So you're going to get 2 times 5 times 4 is 40, blah, 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 with the numbers that you've got there. Let's see if that works out. So here's a gradient with a scalar. This is literally this bit here. All right. Everybody check on that. That makes sense. Yes. Just that simple one. Everyone understood that? Because we're going to hit the double diamond ski ramp here in a second. Yes. Okay. All right. Here is the next one. You're going to do like so. You can print out the values along the way, right? So we can do like so. You get that 40, 20, d loss, dw, dv, which corresponds up here. All right, so now we're going to do the gradient tape with a tensor. So now you got like multiple values you're passing in. If you look at the guy's code, he's putting in like random numbers like this bit. So I don't even know what the numbers are. So I'm not going to do it that way. I want to see the numbers. I know it's a 3 by 2, so I'm going to put the numbers in like this so I can like hand check them because it's happening multiple times. Yada yada yada. The only thing that concerned me, I got that far, but now he's putting the reduced mean in, and I know how to do reduced mean, but I couldn't get the same result. And I know that there's 2 numbers, so you're going to take the half of them. So maybe that's what I'm going to say. But basically, if you were to look at I've got it. I broke it up like he had loss like this. I broke that up into loss all and then loss, so I could then come back and I could do either one. So if I were to do this one. All right, maybe I need to do those stuff before. Sure. Not running everything from the notebook, and we restarted it, so it's not remembering everything. But like there, so that's 44 and 56, and I think I'm only doing like the first row, right? I'm doing this. So that matches the hand calculations. But that doesn't include the loss or the reduced mean. But I would say to myself, if I was going to reduce mean against all, if you look at him, he's doing it with no axis. So if you're doing it with no axis, that's like everything, right? So if you were to do 44, 56 with no specifier on which axis, that comes out to the average across all. And that's where that foo is equal to 50. But he gets a result of DLDV and DW, which is a 2 by 3 and a 2 by 1. So I was a little confused by that, but maybe it's because you're taking the derivative. I don't know. Versus, you do like so. That's what I'm saying. So that matches, but that's not the reduced mean. Now you're 22, 28. So if you know anything about that, you can figure that out. That's something you can get back with me on Sunday when we meet, we do our workshop, and we can talk about it. You guys are the future of America. You're all the young college students. You should know this. That's what I'm hoping you are, because I don't know. I would like to know. I want you to know. All right, so anyways, let's go to his thing. So he's saying, here's a variable, here's x squared, here's dy dx. He's picking the numbers, he's doing 2 times it. He talks about this as, you know, automatic differentiation. It's basically, it's a math operand. The whole gradient tape thing is so you can do backwards propagation, so you can look at the intermediate results. Here it is, yada, yada, yada. He just keeps talking about this. 2 records, keeps going. Now you can go backwards, you can go backwards. Discard the tape. I don't know anything about that. I just know that this is a gradient tape. You set it up. When you do gradient, this is your target. I've added the target and the source. So this is what is going to take the derivative, and this is the source of the variables that are going to go in based on the derivative. I think you can also say, like, I want to do a 2nd order, 3rd order, 4th order. It might be a different parameter. So, like I said, the next set of slides are a little tough. Let's look at the notebook. I think we kind of did that reverse. We did that. So, you know, just totally off the wall, when I was here, when we first got here this morning, I was looking over there and I saw the paper that had like the physics stuff on it, the formulas. So I did take time in here while we were doing it to do the markdown, to do the LaTeX, to do the markdown. So you can see from that formula, go pick it up. It's like, what's the derivative of log x, or what's the integral of log x going backwards, right? You can take the derivative and go this way, and then go yada, yada, yada. So log x, take the derivative, is 1 over x, right? So here it is. Y equals 1 of x. You're going to, yep. Oh, you got a question?
Oh, I was just going to ask.
Yeah, go ahead.
Can you differentiate with respect to like any continuous function?
Yeah, so they go in here and they'll do like you have like an inner and outer function, and he'll take the derivative of like the inner one, but you're working with the outer one. We're going to see that. So I mean, it's whatever, like, and I guess what they're putting behind this is some numerical method, like Runge-Kutta method or Euler's. I don't know what they're doing behind the scenes. I'm just using the API. Okay. But we can look and see what he's doing here. So just doing that backwards, and you can see, like, yeah, 1 over x, what the value is versus doing the derivative. You're going to get, we're putting in log x, right? But we know that's going to produce a 1 over x, and you take the derivative, and so they match. And that was just something off the cuff here. Then now we're into the deep water. With respect to a model, I tried to show you some of this stuff. I'll try to show a little more. So from TF Keras layers dense, the dense API call, the first parameter is the number of, it's the dimension of the output. So if you see 2, that means it's a classifier generating 2 outputs, either class A or class B, right? He shows the reduced mean as part of that, which we somewhat know, but we don't really know how they're doing it. I don't know enough about it. And he's going to take the gradients. He's using the layer trainable variables. I know what that is, because any of the variables that get put into this thing here, they become variables that are trainable. So that's that. I think that's what that is. Then he's going to zip those up, and he's going to put them in here. He's going to print the values, yada, yada, yada. The only thing that I could say is it gets back to what I was doing before. I thought that was going to be 4 and not 3 by 2, but 2 by 2. But I will take their words for it, that they're saying it's the same dimensions, yeah, positive dimension of the output space, and it matches it. But that's your basic neural net, right? You're going to take all your, which we saw before, your weights times your input plus your activation function, which is your bias. Yada, yada, yada. So if you know more about that and we'll talk about it, I'm all ears. All right, so intermediate results. Okay, while we're going to the end here, I can see, and I'm running out of time. So let's keep going. What does he do? So he basically says, we're going to take we're going to do the derivative of this tiny little ML model. So once again, he's setting the activation function, saying he's got two outputs. These are the inputs that he's going to give to it. Meaning that I believe this is going to be 3 values for one particular output. He uses that layer, and then he reduces the mean of y squared. So this is going to be squared. Now, the only thing I think of, because he squared it, maybe he's trying to take like mean squared error. Maybe that's what he's doing. Not exactly certain. This is just, it's a reframable variable. I mentioned that. And this is just zipping up the results for the print. He has speaker comments. Let me just say, slide it up. Calculate the loss between the difference between what the model predicted and what we wanted. Yeah, so that's the loss, which is just what he's going to call it. But we don't know, like I don't see what y is other than this. And so I don't, he's like, what it predicted, there's nothing he's comparing against. I just see this as what that value is going to come through as a result of that function. And don't you normally, when you create loss, you have, this is what I predicted, and this is what that training data should have predicted, right? Wouldn't that be loss? I don't see that. If you do. Same, and he's just showing the output there. This is when you were saying, like, you do any function, whatever. So, if you're not going to be able to do something that's like undeterminate, but you can do intermediate ones. And this is kind of interesting, right? So he's saying R and Z, but when he differentiates it, he wants it respect to both of those. As far as checking his math here, let's look at it for a second. He wants dz dx. So you're going to do this one, there is nothing, so that's R. That's still be R squared. That one would be 2x, I believe. Is that the way it works? I think I did this over here. Yeah. What's the next one? Control flow. So here he's just saying, like, I'm not going to have a for loop, but because these values are coming in, they're being fed to it based upon what the value is at that time, because he's watching it, he will vary the result, right? So that's what's going on here. So you're getting the flow not with a for loop, but you are getting the switch based upon the data coming in. And that's part of the deals with graphs. It's kind of neat. Some technicality, talks about watching, stopping, yada, yada, yada. Yeah, oh my God, there are a lot of technicalities, whatever. I'm just reading this thing. Checkpoint, so what about building whole models? If you're going to build models, you need a thing to collect it because you're going to train it and then you're going to predict it. And you want to like keep this stuff so that you're going to be calling multiple times, right? So you're going to put that in a module and a function. So TF module is the key there. And that's what he's saying here. TF module is a base class for collecting variables, saving them, and checkpointing them. Once again, he gets back to the linear regression. There's your weights, your X, your B. And everybody understands this picture here, pretty simple. What it's basically you're going to do is, here's some data, you're fitting a plot to it. The line is fitted when this dot to here, that's an error, right? This guy from here is an error. And what you're trying to do is look for all of the outputs for the line that you've plotted to minimize all of those collective errors. Ever seen that? Remember that? Yeah, okay, good. That's all that is. And this is a single, right? This is just, your Y is your output, your X is this way, right? So this is why this is just a 2D plot. But then that other thing, remember you had a curve, that's where you've got 2 dimensions and an output, right? That's why that was a curve, right? Create, so here he is, he's going to create a layer. I didn't do these, but I can explain what's going on. This is a class. This is the init, it's called once. The super is going to call the base class. This is setting up the private variables for weights and bias. And then calling it, it does the matrix multiply. The output of that matrix multiply, you see the Y there, that's your activation function. That's the array loop, right? Which, like I said, is 0 and then good linear. How to make a multi-layer model? Well, you're going to put 2 of these layers. And he jumps into this, showing this. So it's yada, yada, yada. So it talks about how to save your models, right? So saving, checkpoint it. We're going to do some of this in a second because he's going to talk about running this with a graph, right? Keras layers or modules, you know. We're almost at an hour. We started at 3:45, it's 4:42, so that's better than I thought. Checkpoint, what about training? Training loops. We're going to kind of buzz through some of this. Applying those gradients was one to get some time. There you go. There's your model that you've got. There's your gradient tape, yada, yada, yada. Let's buzz, making a training step. Yada, yada, yada. So he's going to do some stuff. So here's, all right. So eager versus graph. Back in the day, you would have to do a graph and then you would say run session. So you would say like with session run. We're in eager mode, so we don't have to do any of this right now. But he, like, one thing, he like shows this graph. How does this graph come about? So here's, let's go back and see if the creating the graph is there. Where was it? It might be, he might have shown the graph. Yeah, so he's showing a function like so, creates a function. This is your Python function. Now you've wrapped the Python function as a TensorFlow function. Now you've got a name for that TensorFlow graph. Using it, here's how it's being used. So you can recurse it, but he doesn't show you how he got the previous picture, which is up here. Just to show you real quick. There's the variable similar to what he was doing. There is a function, right? This is the Python function. Now the Python function is getting wrapped by the TensorFlow function. So now you have a TensorFlow op, right? And you can call it, yada, yada, yada. I think this is from, that's my variant. This is his example. And then how did he get to that graph? Here's the reference there if you want to look at it, but we're going to pull up TensorBoard. So by the way, this % is just saying this is not Python code. this is a bash shell script, right? So you're telling the environment, we're going to load this extension. Now you're back in Python, right? Now we're still in Python. Now we're back in bash. We're going to remove any logs that are there. I don't think that's necessarily needs to be done, but he does use this when creates the file writer, he does put it to logs. So this is the same, this is what he did to get that. And now I'm going to go back to a bash prompt to run TensorBoard. I never really did this when I was doing model development. I was more like looking at the training results, and this was just one of the panes. Let's see, it should be loading. Shouldn't say failed. Oh, demos. Let me run this again just for grounds. Because it was there to begin with. I know it takes a while. I think he's just loading. I don't think that he's. I think he is just loading. Maybe he's not. All right. Well, shouldn't have hit Shift Enter. Maybe I didn't step through all of them to do the extensions. Yeah. All right. So that's that. I think he's supposed. I think it'll run, but it's not at the moment. Maybe I need to kill that one. Let me do this. No, I'm not going to do Jag. I think if I were to kill the old one and then come back, that may pull it up. But it's basically, it's just going to show like so, and I don't have. I'm not going to do it. All right, what's the other guy? I'm talking about graphs, how you can do in parallel, yada, yada, yada. What he's showing you how to create a graph with a function. We did this, we went through all that. And he's saying you don't need to use this. Saving was just checkpointing the model. We showed that. A model is just a directory, and here he's showing that, right? So you've got the variables and the checkpoint there. Time differential. We're done. And that's it. Check when we're done. There's so much more. What did we learn? Remember this. So you got data, which is tensors, which go into variables, ops, and all that stuff. Basically, everything is either a tensor or an op. These are the different URLs you can look at. I subscribe to the TensorFlow channel. You'll see a lot of good things. Some things are very intro. It'll get you into it. You can look at it. And some things are more complex. And like I said, I'm happy that you guys let me come and talk to you today. Every Sunday, you can join us for a workshop. And I will advertise. There's another group, which is the RTP Deep Learning Group. Those guys meet on a weekly, semi-weekly basis. They're more like, here's a paper and let's talk about the paper. My group is more like, here's Google Cloud Platform, here's TensorFlow, here's how to do things with them. And that's it. Thank you. Thanks.
I had a question for anyone trying to get into like TensorFlow. What would be like some math, things that were just pre getting into TensorFlow? Items that people should understand.
So so here's the deal. I started out as a math major and really got out of it and was never doing that, right? It's just like someone asked, could you do this, John? I know you have an interest in ML. And I really wasn't doing the math so much. I was doing scikit-learn. Like, you know, I was doing things I didn't know what I was doing, but I just kept at it and began to learn it, right? So I would say, don't even worry about the math to begin with. I saw a guy on LinkedIn. He said, things I would tell myself if I was starting out trying to be a data scientist was don't try to start at the math. But I don't think it hurts, right? If you're interested in it. I took a class, which was, to me, I thought was interesting. It's Intro to Statistical Learning. And it's in R. I've done some R programming. And the guy, there's a book, literally buy a nice color book. And they've got two of them. They've got like the intro one and the bigger one, if you want to kind of come at it from that way. But I think the best thing is maybe just to do it, right? And do it with other people. There's a saying, iron sharpens iron, man sharpens man. That's why I encourage people to come to the group and do it, right? Because now you got somebody that you can ask questions and bounce ideas off. And there's a lot of free stuff out there. I think Google is really cool by putting out these kind of slide decks and stuff. And like I said, I didn't know everything there, but I was happy to kind of learn and let's get it down low like I'd look cool. All right. Guys, hold your beer like this. Don't stand at a party holding your beer like that, right? Yeah. Pro tip. So anyway, anything else? I'm a clown. I like to have a fun time. Okay, well, that's that. Then we're done. Thanks a bunch again. I appreciate it.
Thank you so much, John, for the talk.
Thank you.
So yeah, folks, that's a wrap. The last thing on our list here is the raffle. And so before we get started with the raffle, we have a short, well, not a very short, but still a short form for you all to fill. And that'll get you an entry into the raffle. So let me share that form. I have to look into my emails first. Not to zoom out.
It's hard to see on that thing at the top.
Yeah. Does it show there?
Do we need to look at that or something?
Yeah, I'm putting it into the slides.
Is it that little QR code to show?
Yeah. Not little anymore. All right. So guys, the survey QR code is up here. Hopefully it opens up and you get the survey. The URL, you know what, let me create a tiny URL for this. Just give me 1 second.
Wait, actually.
Before yeah, it's like everybody be a big loves it. That's cool. Yeah, that's what I saw. Yeah, it's like percent. I was like, did Andrew Yang doing that? Yang Gang,
That's crazy. Yeah.
Did you get that a lot?
Back when he was running, yeah. It was every single time I introduced myself. Yeah. Pretty cool, yeah.
I bet the guy was super cool.
Tier raffle, tier survey.
So you
I
had
think
to
John Davis is cool.
I'm part of I'm not the from the alumni. Yeah. So I did that for after college. That's cool. Everyone was rooting for him. I think all the fellows like want to come to my channel.
He really did appeal to me.
He still does.
Yeah.
It's cool.
It is.
Okay, so the tiny link is also on. You can go to tiny.cc/devfestmc, and I'll type it in here as well.
You just click it to the added speaker notes at the bottom.
Yeah.
You gotta let them.
Actually, it is MC reference.
And do we need to create or go to that like generator with all the names, or can we do that?
Yeah, once that comes in, we can. Since in Nashville, Kevin is going to like completely remote. It would be fine like if he gets the t-shirts later. So I'm thinking if we can mail him, that would be like better.
I probably couldn't do it until Friday or like late next weekend.
Gotcha.
And then the week I'm pretty busy. But I can send it to him like Friday, Saturday.
So you were asking if I can drive to Asheville. How far is Asheville from here? I'm leaving for Philly tomorrow, so I got to start work Monday.
Yeah, I don't think you want to drive to Asheville right now.
Asheville is like 3 hours or so. So that's going to be a long time.
Yeah. What does he need him? His thing is virtual, right?
Yeah, this is virtual.
I mean, we can just send him the ones that he wants by mail.
Yeah.
I mean, driving that was kind of a lot. I would do it. It's just if it was in person. It makes sense.
Yeah, we could have made it.
It's just driving 3 hours there.
Yeah.
We got FedEx. FedEx for food. He said FedEx for food. You're FedEx for sure. Do we want to take a picture of them? Do you want me to take a picture of them?
Oh, we can take a picture of everyone.
Sure. We should order mugs. Next time.
Yeah.
I like my mugs.
That would be a good moment. The t-shirts are really good as well.
Went to South Asian conference. I still have my little pingu. Do you want to?
What?
I got a little pingu. One.
Did you get at the end?
You know, the Southern conference. It wasn't a medal. It was like,
Oh yeah, I have that one. Yeah, I have that. Yeah.
it's a love sign.
You know, the stock got the most. Tech got the best.
Well, I just want to say it was really nice. I had a good time, but you've got way more shirts than you needed.
Yeah.
We got some. We have an event in Charlotte.
Oh, you haven't been to Charlotte yet?
Asheville and Charlotte.
Oh, so you're going to take them up there?
Yeah.
Are you going to drive up there tonight or tomorrow?
I'm
He
driving back.
came from Charlotte. So
Oh,
he's
you
gonna
came
drive
from
back.
Charlotte up here, so you're going to go back.
I'm the. We have
Yeah, we talked online.
Yeah.
You had just started your
Yeah.
GG.
Yeah. Charlotte. Should we start?
Cool.
Yeah, we're excited. We have a first like.
I'm just waiting for responses trickling in.
Yeah. Yeah, I looked at, I think you guys are doing like Flutter and stuff tomorrow, right?
Yeah, we have a Flutter talk.
Yeah.
We had Martin O'Malley. He did this. He does like he's a cloud advocate.
Uh-huh.
We had him talk.
Is anyone still filling out the survey?
So like you can't do it.
Okay, I guess we're good to go with the raffle then. So just give us a moment. We'll fill up all the names into the raffle system and we'll spin the wheel and share the screen for that wheel over here. Cool.
Yeah. That's tomorrow.
Yeah, it's Monday,
How often do y'all do the Google developer workshops?
So at GDG, we do workshops. We try to do them every month. And we are always looking for suggestions for any talks or anything. And yeah, we always have speakers who want to come and speak. But we don't have a physical location, so usually it is remote.
Oh, okay.
But the online platform is like, people, first 50 attendees can join, and it's just like a unlimited duration video call.
And that's just on the website itself. We can just
on the
we can see the schedule over
GDG.community.net.
there.
Yeah.
Okay.
You will also get email notifications. And everything.
Okay. Cool. Amazing.
I would say I'd come help you out and do something.
So, there's some wheel of something, wheel of names. Yeah. So you can copy the names and paste them. But we will need those names here. Can you email those names? And I can then open the wheel of.
This is cool because like we're like competing against your parts of the country,
Oh, yeah.
So it's like the more people that we bring to North Carolina, the better.
Yeah.
Yeah, it was a pilot, right? That's the first one.
Yeah, when I've actually held DevFest, but I did them at the Frontier, and the one time I paid money to rent space.
Oh, not here.
It was a lot of money, not that many people would show up, right? And then the other time I just went to the free ones, because the free ones, you have to be during normal working hours, right? And it's a little better. You think you would get more people when you're outside of working hours, but you don't show up, right?
What was I doing? Yeah.
Will.
3 o'clock.
Brain fog.
So, see, that's like, because I'm not familiar with there too much yet. Yeah, so Research Triangle Park, it's supposed to be Durham, Raleigh, Tennessee State, USC Chapel Hill. That's that's kind of what it is, but in reality, it's on the outskirts of Durham to Raleigh. And if you look from the airport.
Do we see it on the stream? Check here, just refresh. Okay.
That's really put like an IBM and all of those big businesses.
All right, guys. So we're ready for the first wheel spin, and there we go.
Wait, no.
And it's William. There he is. Awesome. Congrats. You just won a Nest Mini.
Excellent. Thank you.
Okay. And so if you win one raffle, it doesn't mean you can't win another one. So, yep, the name stays. And now we will spin again. Drum roll, please.
Spin the wheel, Dana. Amanda.
Jaden. Congrats.
Congratulations.
Regular speech.
Oh yeah, definitely go for it.
I'd like to thank my mother and my entire family for bringing me into this world. Thank you very much.
Awesome.
If you want your picture taken by the way.
Perfect. Yeah, so folks, I hope you enjoyed the whole day of talks and nice food and snacks and fun, networking. We really enjoyed organizing this, and I really want to thank John and Miguel, who is GDG Charlotte organizer, and of course Andrew and his whole team, who is the lead here at GDSC at UNC, and everyone else, and Rabimba, who's there at the back, who came here for the talk. He's from Houston. And everyone else who also left but were here for the talks. Thank you so much for coming here. It's been a great time. And before we leave, let's do a photo to remember this day for the rest of our lives. It's been awesome.
Yeah, if you guys could like just come to the first two rows, you can take a picture like that way.
You sure you don't want to go, let's stand there and go that way?
I guess, yeah, we can do it here.
That's probably better. Here we go. Stand here, I think you got room for two.
Yeah, please don't sit in front, sorry. I didn't realize. I think that's better idea.
We got like
Yeah, like.
And stand over here, face that way. So you
Take
can
a picture.
Okay. He's good in the morning. Oh, I thought you were in 2 rows.
Okay, cool.
Hopefully.
He's good in there.
Oh.
We meant to have 2 rows, I believe. Can you get us all in with 1 row?
Yeah. I got it. You guys ready?
Mm-hmm.
So we're gonna do a just natural. 3, 2, 1. And then you do your 21.
You move your hands up.
Does he have like a
Let's do a GDSC, GD1, so we have.
That's model, man. It's like this. Yeah. You have to go like this.
Alright guys, last one. 3, 2. Three, two, one.
There you go.
Thank you guys.
Thank you. Excellent. And you're gonna post those on the event page?
Yeah.
Cool.
Sure.
Is that the like a big tribe of the fact that you
Right, so I'm out. Thank you. Thank you.
I love how you made a card that you're coming on.
Hang on, good to meet you first. Be good.
Thanks a lot for hosting this.
Congratulations.
Oh, thanks.
Is it every Sunday?
Yeah, every Sunday, we have always looking forward to get involved more. We have a organizer meeting at 9.
All right, see you guys.
Thank you. We have an hour of GCP.
Did you get a t-shirt? No. Yeah. Go ahead.
11. Yeah, I'm good. So 10 to 11. 12. I ever close.
Thank you guys for coming.
Because the way it's, I put it on LinkedIn, that's what the same. I've had the same. Yeah, thank you good there. The same meeting you. The calendar is I think goes stale after a while, it needs to be updated, but if you look at the time, it's got a meeting. A lot of times in this meeting, this lady, it's kind of funny, I made her an organizer. Very nice name. What's your name? John. Be good.
Thank you again. I work at institutions.
Yeah, that's a big
Sure, what size? Yeah, congratulations.
For sure, I'll get this. I wanted to bring her, but I wasn't sure.
Welcome.
Yeah, sure. What about an hour?
Tomorrow we have a, if you go to the we have a, which I hopefully. So we'll have a further expert talk to.
And
The slides for so those.
Thank you.
Yeah, of course. Thank you for coming out.
Yeah, no problem.
And probably they should.
I'm leading the way? Why am I leading? Okay.
But then according to the, so I guess.
Yeah, and then I'll say this next one.
Charity and everyone who hires me.
Thanks again. Appreciate it. Thank you. Have a nice.
Stop recording. What was that? Can we stop recording? Oh, is it still recording?
I was gonna clean up.
Wait, did you just say stop recording at the end?
Because if it's already, like if it's a back box, we can return it. No, it's not.
Oh,
Go ahead.
yeah, thank you. Never mind, I'm not gonna keep up.